like downweight certain predictors to be 0. And that's what we're going to do. We're going to ask Lasso to try to basically take all these variables and see which ones we can basically set their weight to 0. So now let's go ahead and do Lasso. So this is just creating a data matrix of X, of just the predictor variables, and then a vector of Y that just contains the outcome variable. And then this is actually doing the Lasso fit. Now with Lasso, you need to remember how I said that it is downweighting the strength of the slope. And in order to identify how strongly to downweight that, you need to basically perform cross-validation. That's doing that internally within that training data set. And so that's what that CV fit object is doing. It's estimating different weights that they could apply and trying to find the best one. And that's where best lambda comes in. So that tells you the weight that we're using to penalize variables. And then we could use this to extract the coefficients. And this is a matrix showing which variables were actually selected. So everything with a dot says that wasn't important enough to include. And then these now contain the regression weights of the Lasso regression. So these aren't the actual regression weights that you would use with a regular regression. They are the downweighted weights. And so now we can go selected variables, Lasso selected. And then now we have an object that tells us which variables were selected, which are baseline, Barthel, and HB, which shockingly was exactly the same variables that I selected using my variable selection procedure. And now that we've done that, let's go ahead and compare the 3 different methods. Now, so I've got a bunch of R functions that I sourced to make some of this stuff easier. It got kind of messy, so I just put it in a separate file. And so remember, in the original data set, when they categorized the outcome and used these weird variable selection strategies, they ended up with these variables: age, NIHSS, Bethel pre, HB, and albumin. Albumin. It's like aluminum, almost like. Bethel pre, by the way, is a categorized version of high versus lower, good versus bad. I don't remember what they call it. And that's what they did, which I disagree with their strategy. But that's what they ended up finding. And so we're going to see some similarities. So again, if we review the ones that I picked, we've got baseline, Barthel, and HB. If we look at the vsurf variables, we just got baseline, Barthel, and then Lasso is baseline, Barthel, and HB. And by the way, and I should probably say this earlier. Now, when comparing these 3, the thing that I want to know is on the training data set, I want to see what a visual looks like. I want to see how the models are differing in their predictions. And so that's what all this mess of code is trying to do, is it's trying to visually compare them. So I'm going to go ahead and generate that matrix. So that's just generating predictions for each of the models and binning it. That's not important what I'm doing there. It's just, again, to get me a visual, which is those 2 lines right there. And I'll put them on one line so you can see them. And so I'm going to go ahead and zoom in on this. So now we've got the 2 models. So let's do some comparisons. So the red is my variable selection method, and then Lasso is in green. So let's just compare those 2 first. Not surprisingly at all, the Lasso has a weaker regression line than the Dustin predictions. Why is that? Again, because Lasso is designed to downweight the strength of the relationship between a predictor and the outcome. And so that's exactly what should happen. That's what it's trying to do. And also both my method, at least at the end, and Lasso are using linear regression. So that's why their predictions are so similar. vsurf, on the other hand, is not using linear regression. It's using decision trees and aggregating decision trees to come up with its predictions. But, and so that's why you get it all bumpy. It's because it's not guaranteed to be a straight line. In fact, rarely, if ever, is it a straight line. But now let's look overall. So we are seeing that as the baseline increases, the follow-up increases too. And it's kind of hard to tell what's going on with HB. I could put that on the x-axis, but I'll reserve that for later. But what we do see is that the 3 models are generating pretty similar predictions. They're not all that different. And all 3 methods chose almost the same variables, except for HB, because vsurf didn't choose that. So now what the original authors did is they withheld 20% of their data as a cross-validation set, and then took the models that they fit in the original sample, and then used the cross-validation set to see how well it fit the data. And so I decided to do the same thing. So I wrote my own function. That's where that's part of what's in there. It's going to use the fit from the training data set to then predict the scores on the cross-validation set. And to do so, it's going to compute a correlation coefficient between the predicted values and the observed values and output a correlation, and it's going to show a plot of those things. So if you look at my model, or my procedure, the correlation between the predicted and the observed is 0.73. So they're highly correlated, which is good, and that's a plot of it. So it seems to be that the predicted scores are really similar to the actual scores. So my version is cross-validating pretty well. Now let's look at the vsurf model. Its correlation is 0.707-ish. So it's doing pretty good. It's not doing as good as my method. And that's okay. So let's go ahead and look at the Lasso fit. And the Lasso is saying that 0.69, so it's the worst of the 3 in terms of correlation coefficients, but all the plots look pretty similar. So yeah, 0.6935, wow, those are the same. Oh, 0.693, 0.701. So in terms of how well they do, my model did the best in this specific data set, followed by vsurf, followed by Lasso. And I just realized I made a mistake. It's a good thing. It's always a good idea to review your code. I was saying vsurf wins. I don't know why I thought a smaller number meant better. No, it's not. vsurf loses. So I thought that was kind of cool that they all gave very similar answers. So let me just summarize. 1, the way the original authors did it was terrible. They artificially categorized an outcome, came up with different variables, and like they gave cross-validation accuracy statistics, but they can't be trusted because they're working with a categorized outcome variable and they're using, yeah, it's just not a good idea. And the 3 ways that I used all gave very, very similar results. And that may be a uniqueness of this data set. It may be that if we tried it on a different data set, we wouldn't have the same thing happen. So let me just talk about the strengths and weaknesses. So Lasso it seems to do a pretty good job. The problem with, and it's very efficient, it's quick, it's not as time consuming as Random Forest is, but the big problem is that it doesn't evaluate interactions unless you specifically model them, as well as nonlinear effects. And so if you have two variables that are interacting and you never get around to modeling that, you're never gonna know that. And Lasso has no way of telling you whether you are missing an interaction. Random Forest, on the other hand, will. But the problem with Random Forest is that it's a non-parametric procedure, and that just bothers my soul. And I've made a video about that, and I've written about that in the literature, that I just feel in my heart and in my soul that the world behaves in lawful ways, and so a non-parametric procedure like Random Forest is never your final destination for modeling. Instead, it's a pit stop to help you figure out what sort of parametric model to build. So VSurf is great, and Random Forest is great for detecting these nonlinear relationships, as well as interaction effects, but it's still, in my mind, just a pit stop. My approach kind of does the best of both worlds, and it wasn't until I started working on this video that it's still missing something. So what it does is it uses Random Forest and its ability to detect nonlinear effects and interaction effects, and it pairs that with visuals to come up with a parametric model. And so we are using Random Forest as a pit stop, and then we fit the final model. The one problem with it, now it didn't pan out in this. I was actually quite surprised to see that Lasso did more poorly than my version, because my version fit both the signal and the noise, or one would assume. So we would think that it wouldn't cross-validate well, but it actually cross-validated better than Lasso did. Kind of interesting, but I wouldn't expect that to always be the case. In fact, I would expect that to not often be the case. So it occurred to me, as I was working on this project, that it might be a good idea to combine all three of these algorithms. So we use Random Forest to do the initial variable selection / identify nonlinear and interaction effects. We build a regular old statistical model from there, and then we take that final model and then subject it to Lasso or ridge regression, which very similar ideas. And maybe I'll make a video about ridge regression versus Lasso and ElasticNet and all those sorts of things. But it would be nice to add a final step that basically takes the final model and then downweights its strength in order to cross-validate better. That sounds like something cool to do. Anyway, let me know if you think that's a good idea. I think it's a good idea. Then it's using like the best of Random Forest, the best of linear regression, and the best of Lasso all in one. It's like the trifecta of amazingness and variable selection. So that's all I got to say about that. As a reminder, if you want to take classes from me, do it. That's all I got to say. No, I'm going to say more. If you want live instruction with me, I teach some live classes. So you can take classes from me either live, where you get to Zoom with me, or you get to take them on your own, at your own pace, through a Canvas course that I offer that has quizzes and discussion boards and stuff like that. So if you are interested, I will leave links in the description, including a variable selection-ish sort of workshop. It's really a data visualization / data mining workshop. And you know what? I think I'm going to add Lasso to that. Why not? Because it's a variable selection strategy. So if you want to take a class from me, please do. I'd like your money. That'd be cool. So with that, I will see you next time. Peace out.
Welcome to our lecture on time series in machine learning. My name is Dr. Andrei Holz, and I will guide you through this topic today. Time series analysis is a critical skill for solving problems where data is collected over time. By the end of this lecture, you will understand the foundations, explore advanced techniques, and learn how to apply them effectively. Time series data is everywhere. Examples include stock prices, weather data, website traffic, and even heart rate measurements. Our goal is to uncover the patterns hidden in this data and use them to predict future values. Let us get started. So, agenda for today. We'll start with the basics, what time series data is and why it is different from other types of data. Then we'll dive into the mathematical background, where you will learn about stationarity, autocorrelation, and other key concepts. Next, we will explore classical models like ARIMA, machine learning methods like Random Forest and Prophet, and hybrid models that combine both approaches. And finally, we will discuss practical tips, such as preparing data and evaluating models, before concluding with the best practices and key takeaways. This structure will help you build a step-by-step understanding from fundamentals to advanced techniques. And time series analysis is one of the most applied areas in machine learning. It is used in industries like finance, healthcare, manufacturing, and marketing. For example, predicting sales helps businesses plan inventory. Detecting anomalies in system logs can prevent server failures. In time series, the main challenge is accounting for the fact that data points are not independent. Instead, they are related through time. Models must understand these relationships to make accurate forecasts. A time series is a set of data points collected in chronological order. Think of daily temperatures over a month or hourly website visits. What makes time series unique is the order of the data. It matters. Unlike other data types, you cannot shuffle time series data without losing its meaning. For example, if you analyze sales data, today's sales may depend on yesterday's promotions or seasonal patterns like holidays. Time series can be broken into 4 main components. Trend, the overall direction of the data, whether it's increasing, decreasing, or stable over time. That's the second from the top here, the green one. Seasonality is irregular, repeating patterns, such as high sales every December. So, for instance, they are here like the third one from the top, seasonality. And irregularity, or random noise, or residuals, is just fluctuations that cannot be predicted. And understanding these components helps us select the right model and pre-processing techniques. For example, trends and seasonality can be modeled explicitly, while irregularity is treated as a residual error. By the way, sometimes is the cyclicality involved. It's a long-term pattern, not tied to a fixed calendar like economic booms and recessions. So if you can also include this in your analysis. And this makes this time series unique, unlike regression. And yeah, you can see this is the actual decomposition of the top graph, and the top graph is the Bitcoin price actually. So let us get moving. And what is the trend like mathematically? Well, we can calculate it by moving average or by polynomial fitting. Basically, we use smoothing techniques to identify this trend. Seasonality is extracted by observing regular patterns, often using decomposition techniques like STL. Again, you can just use the observed data and subtract trend from this data, and this is like one of the ways to calculate seasonality, because now we do not have trend, like you can try to see what is going on. As for the cyclicity, unlike seasonality, it has no fixed period and is often explored through spectral analysis. And finally, irregularity or noise or residuals, it's just random variations, and it what remains after accounting for all other components. These calculations helps us understand and model the data more effectively. As you can see, you can have your observed data and subtract trend and seasonality from the observed data, and now you will have the noise. You might have an idea, well, let us use regression models, since they predict the value, not the class, and predict time series. The main issue is that regression assumes all data points are independent. However, in time series, data points are often correlated. For example, if it's raining today, it is likely to rain tomorrow. A regression model wouldn't account for this relationship, leading to inaccurate predictions. Time series models like ARIMA or Prophet are specifically designed to handle temporal dependencies. Regression models struggle with time series for several reasons. They ignore autocorrelation, the influence of past values on current ones. They cannot model trend or seasonality without extensive manual feature engineering. They assume data points are independent, which is not true for time series. For example, predicting sales using regression would require you to manually create lag features and seasonal indicators, which can be tedious and could lead to errors. Mathematical foundations are critical for understanding time series. And one key concept is stationarity, which means the statistical properties of the data, like mean and variance, remain constant over time. Most time series models require stationarity because it ensures the data's behavior does not change unpredictably. You can take a look at this image. So how stationary time series on the top differs from the non-stationary time series. And I would say this is pretty interesting. You can see that the stationary time series are inside the boundaries, while non-stationary time series, they change their behavior. They either grow or there is a standard deviation that is changing. To check stationarity, we use tests like ADF or augmented Dickey-Fuller test. Tests if data has a unique root indicating non-stationarity, and KPSS tests for stationarity around a trend. If the data is non-stationary, techniques like differentiating or detrending are applied. So what is stationarity from the mathematical point of view? Stationarity can be weak and strict. For weak stationarity, only the first two moments like mean and variance are constant, and autocovariance depends only on the lag between observations, not on the actual time. If we're talking about strict stationarity, then all statistical properties like mean, variance, and higher moments are constant over time, and it implies that the joint distribution of any collection of time points is invariant to shifts in time. So this is indeed really a strict condition. In practice, most of the time series are weak stationary. What about testing time series? Well, as I mentioned, there are two main tests. There are a lot of others, and we can use ADF test, and the null hypothesis there is the time series has a unique root. It is non-stationary, and alternative hypothesis is the time series is stationary. So how to interpret? A low p-value leads to rejection of the null hypothesis, indicating stationarity. As for the KPSS, so the null hypothesis is the time series is stationary, and alternative hypothesis is the time series is non-stationary. It's like the opposite to the ADF test. And interpretation of this hypothesis, so a low p-value leads to rejection of null hypothesis, indicating non-stationarity. And what about testing for stationarity? Well, there are a lot of tests, and variations of tests. We'll take a look at two: the augmented Dickey-Fuller test, or ADF, and the null hypothesis here is the time series has a unit root non-stationarity, and alternative hypothesis is the time series is stationary. So how to interpret it? A low p-value of this test leads to rejection of the null hypothesis, indicating stationarity, and KPSS test as like null hypothesis here is the time series is stationary, and alternative is time series is a non-stationary. How to interpret it? A low p-value leads to rejection of the null hypothesis, indicating non-stationarity. So this is a like alternative version, or like the opposite version of the conditions of the first test. But let us move on. And what about the autocorrelation and partial autocorrelation? The autocorrelation function shows how strongly the data is correlated with its past values at different lags. For example, if sales are strongly correlated with the previous week's sales, and this will appear in the ACF plot, or the autocorrelation function plot. The partial autocorrelation function, or PACF, isolates the direct effect of past values, removing indirect effects. And those plots are used to determine the order of the autoregressive and moving average components in models like ARIMA. The partial autocorrelation function quantifies the correlation between a time series and its lag values. After removing the effects of intermediate lags, it isolates the direct effect of a lag on the current time step. And what about the practical implications? So those plots are used in the stock prices to determine short-term dependencies and moving average patterns in financial data, weather forecasting to identify lagged relationships between temperature values, and energy consumption, of course, to analyze autoregressive patterns in electricity demand. And this is how they look like, those plots of the original time series. And let us discuss those graphs and their essential tools for time series analysis. So ACF plot on the left measures how strongly time series is correlated with its past values or lags, and each vertical bar represents the correlation at a specific lag. For example, the first bar corresponds to how today's value relates to yesterday's, while the second bar shows the relationship with the value 2 days ago, and so on. The blue shaded area represents the confidence interval. Bars outside this area indicate statistically significant correlations, while bars within it are considered random noise. And of course, at lag 0, the correlation is always 1, because time series compared with itself, so it's mathematically. A sharp drop after the first lag suggests like a moving average process. A gradual decline or decay indicates an autoregressive process. What about the right panel, this one, the PACF plot? It measures the direct relationship between the time series and its lagged values, excluding the effects of intermediate lags. For example, at lag 3, the PACF removes the influence of lag 1 and lag 2, showing only the pure correlation at lag 3. And similar to ACF, bars outside the blue shaded region are significant. A sharp cutoff after a certain lag suggests an autoregressive process. For instance, if only the first lag is significant, it indicates the autoregressive 1 process. How to analyze those plots? In the ACF plot, we see a significant bar at lag 1, followed by a sharp cutoff. We're talking about the left one. This suggests a moving average process, MA1. In the PACF plot, we see a significant bar at lag 1 and no significant bars afterwards, which indicates an autoregressive process, likely AR1. And from these plots, the time series appears to follow the specific patterns. We'll discuss it during the practical session. So one AR term in a RIMA model, no differencing, and one MA term. And this model captures both the autoregressive and moving average components identified in the graphs. Let us have a coding session where we'll take a look at the time series decomposition and analysis. Hello, this notebook demonstrates advanced techniques for time series decomposition and diagnosis. It focuses on separating time series into trend, seasonality, and residuals using custom calculations and the STL decomposition method. Additionally, it includes diagnosis to analyze stationarity and suggests ARIMA parameters based on dataset properties. Let's start with the dataset and decomposition. So the first approach is to calculate all manually, and to calculate the trend or moving average, we need to apply rolling window with the seasonal period of 12 months. And this is how we calculate the trend. This smoothes the data to reveal long-term patterns. As for the seasonality, after we have trend, seasonality is calculated by averaging detrended values for each month. For example, the average deviation in January helps identify the seasonal index for January. And these seasonal indices are normalized to ensure they sum to 0, highlighting cyclical fluctuations. This is exactly what we do here, like with seasonal indices. Then we need to map the indices to the dataset, calculate residuals. So now we're just having the observed data and we're subtracting trend and seasonal components. And yeah, then we'll plot it. And yeah, basically, let's take a look at what we have here. Just wait a little bit. Yep, the original time series, the trend component. So the trend is rising. So yeah, more and more people are traveling. The seasonal component, we can see here that there is a pattern and like, or there is a seasonality here. And the residuals that we manually calculated are pretty interesting, I would say. What next is we can calculate the same thing, but with the stat models decomposition. So let us take a look, and we will use this pre-made function that calculates everything. Yeah, original time series, trend component, seasonal component is a bit different since we're using another tool, and the residual component. What if we have like the seasonal of 12, not 13? Just let's take a look. So what? Tool. and the residual component. What if we have like the seasonal of 12, not 13? Just let's take a look. So what happens? Again, seasonal must be odd positive integer. Okay, 11. Oh, yep, the residuals seem to be different. But yeah, let's return to be 13, since that's the standard number for the yearly seasonality. And STL decomposition, or seasonal trend decomposition using LOES, is a more sophisticated method. It represents a time series into trend, seasonality, and residuals. I showed you how it works, and seasonality captures like repeating patterns, and residuals represent the noise of variations explained, not explained by trend seasonality. Let us have some diagnosis. So what we do here, we apply several tests, like a Dickey-Fuller test, and we apply KSSP test for stationarity. Then we'll analyze the plots of ACF and PACF and to calculate some insights for the parameters of the ARIMA models. Yeah, and let's take a look how it works. So yeah, Dickey-Fuller test says that the series is likely non-stationary, and this is true since that's it. We have a trend here, upcoming trend. And the second test also says that it's likely non-stationary. So differences here suggested orders, and yeah, series is non-stationary. Differentiating is required. So this is what is required, and yeah, we can later use it. As for the lags in ACF, like significant lags in the ACF plot suggests the order of MA terms, and significant lags in PACF plot suggest the order of AR terms. And we will use it later. Keep in mind that, well, those things helps us evaluate the model and choose the best parameters for our models. Stationary check summary of orders, and basically, yeah, we calculated all that we needed. Let's try apply difference and check what if we apply difference. We can see here like the difference here, but the time series now is likely stationary, so we can operate with this one. So this notebook was to practically demonstrate how to decompose time series into components for better understanding and pre-processing. And diagnostics we also showed to evaluate stationarity and determine the need for transformations. So this notebook equips you with the tools for analyzing and understanding time series. Decomposition methods reveal the structure of the data, while diagnosis ensures appropriate model selection. Feel free to experiment with the data sets and parameters to deepen your understanding and knowledge. And thank you. Welcome back, and let us continue. Now, let us talk about how we actually model time series. So what should we do and how to approach them? And we already mentioned ARIMA model, so let's take a look what it actually is. And ARIMA is the autoregressive and integrated and moving average, so that's like the letters in the name. It models the relationships between three main components: the autoregressive component, the integrated component, and the moving average component. Mathematically, they are described in the slide, and as for the parameters, we have the P, D, and Q. P is the order of the autoregressive part, and determined using the PACF plot, as we discussed, and D is the degrees of differencing. It determined by examining the trend and stationarity of the time series, so the time series should be stationary. So if it is not stationary, we try to apply differencing to it. And the Q is the order of the MA, or the moving average part, and it is determined using the ACF plot, where significant lags indicate the MA order. For example, if sales are consistently increasing, ARIMA can identify this trend, remove it, and focus on the residual patterns. So ARIMA extends ARIMA by adding seasonal components. This is useful for data with repeating patterns like quarterly sales. It includes parameters for seasonal autoregression, differencing, and moving average, capturing both short-term and seasonal dependencies. And here we have three parameters that are the same as we had in ARIMA, and one more. So the parameters we had in the ARIMA is the order of the autoregressive part, or degree of differencing, and order of the moving average part, but now they represent also the seasonality. And the new parameter is the number of time periods in one seasonal cycle. For instance, like 12 months for monthly data with yearly seasonality. And this is how the ARIMA works. You can take a look at the mathematical implementation, and let us have the summary. We won't dive deeper here, since that's an overview of the time series, and we'll need a separate topic specifically for time series to discuss all in details. But as for the summary, so the strengths of the ARIMA and SARIMA models, well, they're well understood and they are interpretable. There are basically coefficients, and we know how the coefficients are calculated. They're effective for linear patterns and stationary data, or if the data can be reduced to stationary by some operations. The assumptions of those models are so linearity in data relationships, stationarity after differencing if necessary, and normality in residuals. And what are the limitations? Well, they struggle with nonlinear patterns. They require careful parameter tuning, and it is pretty hard for them to handle exogenous variables. It means that the model does not natively include a mechanism to incorporate external factors, variables that are not part of the time series itself, into the calculations. And these external factors are called exogenous variables. They can influence the time series, but are not directly derived from it. Just as an example, if you are forecasting monthly sales, price discounts or advertising spend could be exogenous variables because they affect the sales, but they are not part of the historical sales data. And that would be pretty hard for those models to include them. What about the machine learning? Since, like, we already know some machine learning models, can we use them in a way? We can use some models, for example, random forest, and they're flexible enough and handle nonlinear relationships, unlike linear regression. And those models do not require the data to be stationary and can incorporate external features such as weather or holidays into predictions. So you can use them, but you will have to have the feature engineering part done on your side completely, because those models are not specifically designed for time series. They're general models. So, and if we're talking about tree-based models, well, we can use decision trees, random forest, gradient boosting machines, and the features that you will definitely completely, because those models are not specifically designed for time series. They're general models. So, and if we're talking about tree-based models, well, we can use decision trees, random forest, gradient boosting machines, and the features that you will definitely need to incorporate is the lag features, is the rolling statistics like moving averages, moving standard deviations, and so on, and time-based features like day of the week, month, quarterly, holidays, and so on. And the advantages of using those types of models is they can handle nonlinearity and interactions, and they are robust to outliers, unlike RIMA and SARIMA, and they can provide feature importance insights, which might be pretty interesting and crucial sometimes. If we're moving to the models specifically designed for time series, well, the one that is interesting is the Prophet by Facebook or Meta. It is specifically developed for forecasting time series data, and it is designed to handle seasonality, holidays, and trend changes. The key features of this model is the additive model components, trend seasonality holidays, and automatic change point detection, and user-friendly with minimal parameter tuning. As for the advantages and use cases, so it handles missing data and outliers well. It is suitable for business forecasting like sales, demand, and so on, and it is scalable and easy to use for non-experts. Let us talk about the features that make Prophet a wonderful and flexible time series forecasting tool. It uses additive model, meaning it breaks down the time series into key components, trend, seasonality, and holiday effect. And the components are modeled separately and then added together to form the final forecast. Mathematically, the model is represented as the equation. One part represents the trend, capturing the overall direction of the data, whether it's increasing, decreasing, or constant. The next one is seasonality, which models repeating patterns like weekly or yearly cycles. And then the next one captures holidays or special events, such as sales spike during Black Friday. And finally, the final term is the random noise or residuals that cannot be explained by other components. And by separating these elements, Prophet allows us to analyze their individual contributions to the time series and understand how the trends, seasonality, and holidays influence the data. One of the Prophet's standout features is the ability to automatically detect change points. Change points are moments where the trend changes direction or slope, such as sudden increase in demand or sharp decline in sales. This feature is particularly useful for data sets with unexpected shifts. Instead of requiring manual intervention to identify those changes, Prophet adapts automatically, making it easier to work with the real-world data that is often unpredictable. And yet, just look at the charts. Top one shows the trend component, captures the overall increase over time. The next one, the second one, is holiday effects, showing how specific dates impact the data. And then the third one represents weekly seasonality, indicating variations across the days of the week. And the last plot is the yearly seasonality, reflecting patterns throughout the year. Prophet's structure and change point detection make it user-friendly and effective, especially for business data. It provides flexibility in handling trends, seasonality, and events, while also being robust to changes in the data. And these features make it an excellent choice for time series forecasting. What about the hybrid models? Hybrid models combine the strengths of ARIMA for capturing linear trends and machine learning for handling non-linear relationships. You can think of it as an ensemble. For example, ARIMA can remove trends, and random forests can model the residuals to improve accuracy. An advantage of those techniques is that it enhances predictive performance and reduces the risk of overfitting and increases robustness to different data patterns. The tricky part here is you need to carefully design this approach. Otherwise, well, it's pretty hard to make different types of models work on the time series data. Please also keep in mind that you need to validate the time series in a way that differs from the classical machine learning regression. So you'll need to keep in mind that you cannot randomly shuffle the data. And there are also other notable methods. We won't stop here to discuss them since they require a separate session. I'll just briefly mention them. State space models are flexible for representing time series with unobserved components, and they're allowed to break down a time series into parts like trend, seasonality, and noise, while also accounting for latent states that are not directly measurable. One widely used tool is the Kalman filter, which is like the iterative algorithm to estimate these unobserved states efficiently. It is particularly useful in dynamic systems such as tracking moving objects or predicting financial time series in real time. Of course, Gaussian processes can be used here, and the key advantage is their ability to handle uncertainty explicitly, providing not only predictions but also confidence intervals. And this makes them especially useful in areas like geospatial modeling or forecasting, where uncertainty plays a critical role. And of course, transformer-based models are one of the most recent advancements in time series analysis. Originally, they were developed for natural language processing. However, they use attention mechanisms to capture long-range dependencies in the data. And by focusing on the most relevant parts of the time series, transformers models can handle complex patterns and relationships that traditional methods often struggle with. And they're now considered state-of-the-art, and many time series applications such as demand forecasting and anomaly detection use transformer-based architectures. And the advantages of these methods is the flexibility. They can model complex patterns and uncertainty estimates, and the performance. Especially transformer-based models have demonstrated state-of-the-art results in tasks requiring high accuracy, particularly for long-term and large-scale forecasting. And those methods gives us tool to solve the complexity of modern time series problems, especially when working with large datasets or in highly dynamic systems. Let us have a demo. We'll take a look at several models on the real dataset. Let us walk through a hands-on example of time series modeling. This notebook demonstrates a complete workflow from data preparation to applying various models like SARIMA, Random Forest, Prophet, XGBoost, and finally evaluating their performance. Let's break it down step by step. And the first step is installing and importing required libraries. So here we'll need stat models, scikit-learn like XGBoost and Prophet by Facebook or Meta. It specializes in time series forecasting. Once installed, we import the libs for tasks like data handling, pandas, visualization, matplotlib, and statistical analysis, stat models, and machine learning. Let us move on. So I already installed it, so not a big deal. Data preparation. I created everything in a function way. So this is the simplest data preparation. The dataset is actually downloaded from the URL that I provide. Then all the missing values are dropped since we do not need missing values here. Again, this is for the demo purposes. In the real case scenario, you'll need to impute the missing values based on some logic, but we can plot the original data, and this is data on the airline passengers dataset. Contains mostly passenger numbers. Let us take a look at it. So what is going on? We'll take a look at it later. So basically we have here two differences. Here passengers original data, so nothing special. Common functions we'll need. Yeah, but by the way, differencing. To make time step series stationary, we apply differencing, and first order differencing removes threads. Second order differencing addresses seasonal patterns, and the visualization here will also be provided. So what about the evaluation of the models? To evaluate and plot, and this is critical for our understanding, we'll use RMSE, root mean squared error, MAE, mean absolute error, and MAPE, mean absolute percentage error, to quantify predictions. As for the and MSE also, as for the visualization here, we also have the QQ plot of the residuals to check, and the histogram of the residuals. Again, Shapiro test for normality also included, and then analytics of the QQ plot just to help you understand what is going on. We can move on to the models actually. So, and the SARIMA model is a classical time series approach that models trends and seasonality. It uses the difference series and seasonal parameters to forecast. We specify the SARIMA configuration as 1, 2, 1 for non-seasonal components, and 0, 1, 1, 12 for seasonal components, meaning that those parameters indicate how we're using the differences, how we're using the auto-regression. We're moving to the random forest and let's say tree-based algorithm, and to adapt it for time series, we create lag features like lag 1. Again, this is for the demo purposes, and we can create a lot of lag features here. That's just a demonstration. And when moving to the Prophet model, and the Prophet requires the data to have timestamps and a variable, ds for date and y for values, and we prepare this data. Then it will automatically handle change points, provides interpretable plots and components like trend and seasonality, and the components are visualized to understand the underlying patterns. So let's move to the XGBoost. XGBoost is designed in a way to do similar to the random forest actually. And here we have the main flow. Let's take a look at it. So we have original data. Obviously, there is a trend, and the number of passengers is increasing year by year here. As for the differences of the ACF and PACF, so we can see here that, well, there is high correlation between the 12 and the 12, meaning that, 12 and 24, meaning that the yearly seasonality still exists. Let's run our first model, SARIMA, seasonal ARIMA. We can see here that the QQ plot here shows almost good pictures of the aligned to theoretical quantiles, and the overall prediction is not that bad. It resembles the pattern actually, and the MAPE on the holdout dataset is 4%, which is pretty good, and all other metrics are again nice. So the residuals here not seem to blast, and histogram is around 0. We can also have this table, take a look with all the statistics, but let us move on. Histogram of the residuals. So what residual analysis shows us, residuals are likely normally distributed according to Shapiro test, and QQ plot says that our residuals align closely and they are likely to be normally distributed. So all in all, we're pretty good with this model. What about the random forest? Let's take a look. It behaves worse, but again, keep in mind we're using only one lag feature here, so it's random forest with one feature, and it's maybe 12%. Let's move to the analysis. Well, analysis of residuals, again, pretty good. Let's take a look what Prophet shows us. And for the Prophet, we have a MAPE of 7%, almost 8%. We have yearly seasonality, which is pretty interesting. So that the summer time, except for the July, so it's June and August, in a pike, maybe this beginning and the end of the vacations. And some highlight in January. Again, the trend. Let's move on. The QQ plot is a bit worse than for the SARIMA model, but still looking pretty good for some of the quantiles. So the residuals here are not normally distributed according to our tests. What about the XGBoost? Let's take a look at the XGBoost model. So we evaluate the model. Let's take a look at the MAPE. MAPE is 13.5%, and the QQ plot is not that good actually. So, but the residuals are normally distributed according to the statistical test. Let's have a summary table for us just to visualize, and we can see that the top champions are the SARIMA and the Prophet. But on the holdout dataset, so just the test dataset, let us use cross-validation to double check. Maybe we're just lucky, but we need to have a stable prediction. Just let us wait a little bit. It won't take long. We have the data. So what is Interesting. Let's take a look at the MAPE. Surprisingly, the MAPE for the Prophet is lower than the MAPE for the Surima, so maybe there was not enough data for the Surima to utilize for the small amount of data. Let's build some graphs. So for this particular scheme, the Prophet seems to be a winner. However, on the pure holdout dataset, Surima model prevails, and those are graphs for MSE and MAE. Let's take a look at the MAPE. Again, yeah. So with this in mind, as a recommendation, I would choose to double check the Surima model and Prophet model and maybe choose one of them, because yeah, this notebook demonstrates how to approach time series analysis with diverse modeling techniques, from classical statistical models like Surima to modern machine learning approaches like random forest, XGBoost, and specialized tools like Prophet. The key takeaway is the importance of evaluating models and use both metrics and residual diagnosis to ensure robust forecasting and real-world applications. And do not forget to use cross-validation. And feel free to modify the parameters, and this notebook will be shared with you, and apply these techniques to other datasets to gain insights. And thank you. Welcome back, and let us continue. Let us discuss some practical considerations in time series modeling. Before building any time series models, and proper processing is crucial to ensure accuracy and reliability. And let us break down this process into three main steps: handling missing values, differencing, and transformations, and like scaling and normalizations. Handling missing values, there are a lot of approaches, and what differs some approaches from the classical ones, like from the ones in regression or in classification, is like forward fields and interpolation, because we should keep in mind that there is a temporal information also. So you should fill within some kind of window, or like use any sophisticated logic, since it's a time series and the order is important. And differencing helps remove trends and seasonality, and there are different ways how to difference the values. As for the transformations, well, log transform, square root, just to stabilize variance, and of course scaling and normalization, they are important for machine learning models, and like you can use techniques as min-max scaling and standardization, but also keep in mind that sometimes you'll need to apply those in the rolling window, otherwise you will scale the whole dataset, and that might not be the best solution. To give you some examples, well, transformations like log or square root are applied to stabilize variance and reduce the impact of outliers. For example, if your data shows high spikes, taking the log can compress those peaks and make the data more uniform. If we're talking about like scaling, so imagine that you're working with the stock prices that range from $10 to $10,000. Scaling ensures the model treats these differences fairly, rather than just overweighting the larger values. And handling missing values, applying transformations like differentiating, scaling, and like all fundamental steps in pre-processing time series data, that are important. They help your model make more stable predictions. They help your model to be more stable. And these steps ensure the data is clean, consistent, and suitable for accurate modeling. And what about the feature engineering? So it is one of the most critical steps in time series analysis, and it helps the model better capture patterns and dependencies in the data. And let us explore three key techniques: lag features, rolling statistics, and time-based features. As for the lag features, they're created by using past values of the time series as predictors for the current value. This is based on the assumption that the past data points have an influence on the future values. For example, if you're forecasting sales, you might use the values from the day ago and 2 days ago, like also as an input features, and like they're mathematically represented just like this. What about the rolling statistics? It involves calculating metrics like moving average or moving standard deviation over a specific window of time. And these features help smooth out short-term fluctuations and highlight long-term trends or variability in the data. And like example is 7-day rolling average can give a smoother view of daily sales trends. Similarly, a rolling standard deviation can be used to capture periods of high or low variability in the data. Of course, there are time-based features. Like imagine you need to encode the month, and if you apply the label encoding, the December will be like the 12th month, and the January will be like the one. And it is pretty bad if we're talking about time series, because those 2 months are close to each other. But if you use the label encoding, they are just super far away. Time-based features are derived from the temporal attributes of the data, such as the hour, day of the week, month, or quarter, and they're useful for capturing seasonality or recurrent patterns. And for cyclic features like months or hours, we can encode them using sine and cosine transformations to preserve the cyclical nature. And this avoid issues where December and January seem far apart numerically, but they actually like close to each other. These transformations are one of the ways. There are several options to do so. And just to summarize, so leg features help capture past dependencies, and rolling statistics highlights trends and variability. Time-based features, especially with cyclic encoding, allow the model to capture seasonality and recurrent patterns. And feature engineering ensures that the model has all the necessary context to make the accurate prediction, which is especially important in time series forecasting. But as I mentioned, we also need to keep in mind the data splitting. So the simplest approach is to train the model on past data and test on the future data. For example, if we have 10 years of data, we can train the model on the first 8 years and then use the last 2 years for testing. This ensures that the test set reflects future that the model has not seen. For better model evaluation, we can use time-based cross-validations, and there are 2 common strategies. The first one is rolling window, and the train set expands over time, including more past data as we move forward. For instance, if the first fold we might train on the first year and test on the second year. In the next fold, we train on the first 2 years and test on the third, and so on. So we extend. There is also a sliding window, and in this method, both the training set and test set move forward in time, maintaining a fixed size. This is useful when the system's behavior changes over time and we do not want older data to dominate the model training. These methods provide a more robust evaluation by testing the model on the multiple time periods. And please avoid common pitfalls. The biggest pitfall in time series splitting data is data leakage, where future information influences the training set. This happens a lot, and this can happen if, for example, rolling averages or future time points are included in the training set. Another common issue is failing to generalize the model to future data, which can result from non-testing on unseen time periods. Always ensure your test set contains data points from a future time period that the model has not seen during training. Take a look at the diagram. In the first row, the data set is split into one training and one test set, following a simple time-based split. And in the second, we extend the train set and move the test set, and we go sequentially. Just as a summary for this, always maintain temporal order when splitting time series datasets to prevent data leakage. Use simple time-based splits for straightforward evaluation and time-based cross-validation methods like rolling or sliding window for more robust model assessment. By applying these strategies, we ensure that our models are evaluated realistically and perform well on future and unseen data. Since we talked about this, how we evaluate, which metrics would we use? As for the metrics, it's straightforward. We can use metrics from regression, basically mean, which metrics would we use? As for the metrics, it's straightforward. We can use metrics from regression, basically mean absolute error, root mean squared error. Mean squared error may mean absolute percentage error. Sometimes it is wise to split the test into the periods if you have big test, and just to validate how your error increases over time. And also keep in mind that you should apply a residual diagnosis, and you should check autocorrelation function, and you can check the normality of residuals by using QQ plot and tests like Shapiro. Residuals should be normally distributed. One more interesting metric is the statistical metrics for model selection. If you have several ARIMA models, you need to choose one. Well, you can use Akaike information criteria, and lower values indicate a better model. And yeah, typically it is used for selection of the models. You can use also the Bayesian information criteria, so it depends which one would you like to use. One more thing to mention, confidence intervals in time series. When forecasting with time series, it is important not only to provide a single prediction, but also to quantify the uncertainty around that prediction. This is where confidence intervals come in. A confidence interval gives us a range of values within which we expect the true value of the forecasted variable to lie, of course, with a specified probability. For example, a 95 confidence interval means that 95% of the time, the actual value is expected to fall within this range.
Mm.
And this range accounts for uncertainties in the data and the model. And in the graph, you can see the orange shaded region, and it represents the confidence interval around the forecast. And the center line is the predicted value, and the intervals provide a range of uncertainty, widening as we move further into the future. And the confidence intervals are important. They are sometimes critical for decision making because they provide a measure of uncertainty. They help you understand how much trust you can place in the forecast. For example, if the intervals are very wide, the precisions are less certain. In fields like finance or inventory management, knowing the range of possible outcomes helps organizations plan for the best and worst case scenarios. And of course, confidence intervals provide context to stakeholders, showing that forecasts are not exact but come with a range of possible values. How to estimate the confidence intervals? There are a lot of methods. We'll briefly take a look at a couple of them. Since we understand that confidence intervals are important, we'll begin with the classical time series models. Basically, the models have built-in mechanism like ARIMA and SARIMA, and they estimate those confidence intervals. They calculate the variance of residuals, the difference between actual values and predicted values, and use this variance to construct prediction intervals. For example, when
you calculate confidence intervals for neural networks? That's a good question. Or like machine learning techniques more broadly. Because I don't know, I think the important thing is just explaining the data, explaining like how you're doing it, right? Like he just sent me a bunch of data sets that are just like no explanation what is used, how it's implemented. It's just kind of like it's there, right? Like, I don't know, man, like at least explain like what I'm looking at, what you're trying to get out of this plot, like everything like that. Just kind of like make it reasonable for me to kind of understand, right? Like, I'm gonna be honest, like I don't know if like every single person who's gonna look at these kind of papers are a fucking master in time series data analysis, you know? Like, I feel like that's the kind of point of the paper, is that like we're kind of trying to learn together. We're not kind of like trying to just, okay, let me just spew all this information and you who's like really good at figuring it out, you'll figure it out, right? It's so stupid. Kind of like learn together, right? What I'm trying to say there is like you make a paper, you say like, okay, here's the methods, here's the observations, here's everything that we used, here's why we used them, like here's what we're trying to achieve, and here are the results, and here's what we think about the results, right? And it's kind of the same shit here. It's kind of like I feel like what he just did is just kind of like, okay, here's the results, what the fuck do they mean, anything like that, like how did we achieve them, like whatever the fuck. Is just kind of like, yeah, figure it out, bro, you know, like figure it the fuck out. Like, I don't know, I don't feel like that's how research that's how a research report should be written, at least. Or like, I don't know what he kind of like what he wants me to do. Like, does he want me to just put this shit into there? Because like, I would make sense, but like, have you even looked at like my task? Like, I've done task 1. You've seen, like, if you read through all the stuff that I've done, you can see that, like, you know,
forecasting with ARIMA, the model generates upper and lower bounds based on the variability in historical data, assuming a normal distribution of errors. And this allows us to capture the range of likely outcomes of future predictions. As for the tree-based models, like random forest gradient boosting, while there are quantile regression forests, tree-based models can extend to quantile regression to estimate the specific quantiles, such as the 5th and the 95th percentiles. And this provides direct prediction intervals instead of just a point prediction. And it is useful when data distributions are non-normal or symmetric. Bootstrapping is another method commonly used with the tree-based models, and we resample the training data with replacement and train multiple models, and then form the predictions of those models and create distribution and calculate percentiles to determine the confidence intervals. And the methods work well, like when you don't have like built-in intervals, but want to capture the uncertainty in the predictions using like statistics. As for the profit, well, it has a built-in prediction intervals. It includes variability in trend, seasonality, and other components to estimate prediction intervals. And by default, it provides 80% and 90%, 95% intervals, but these can be adjusted based on the application. And this makes, again, profit interesting model and useful for practical scenarios. And regardless of the methods used, there are a few best practices to keep in mind when estimating and interpreting confidence intervals. The first one is choose appropriate confidence levels. Select intervals that match the context of a problem. For instance, in financial risk assessment, 95% confidence might be appropriate, while 80% might not be enough. Assess interval width. Wider intervals indicates greater uncertainty in the model. If intervals are too wide, it might signal in a need like to improve the model or to clean the data. A narrow interval suggests the model is confident, however, may risk underestimating variability. And of course, like validate confidence intervals, compare predicted intervals with actual outcomes to ensure that they're well calibrated. For example, if you predict a 95% confidence interval, about 95% of the actual values should fall within that range. And just to sum up, different models provide various ways to estimate confidence intervals. And classical models rely on residuals variance. Tree-based models use quantiles and bootstrapping, and Prophet simplifies the process with built-in intervals. But remember to validate and interpret the intervals carefully to make informed and meaningful decisions. And we're moving to the advanced topics and best practices, dealing with seasonality and trends. And there are advanced techniques like using complicated models and capturing complex seasonality. And you can use seasonal trend decomposition using like STL and decomposes time series into trend, seasonality, and residual components effectively. There are also exponential smoothing methods that captures like trends and multiple seasonalities and nonlinear dependencies. And of course, like there are various ways to decompose time series. We can use differencing, we can use polynomial fitting just to model nonlinear trends, and we can use like other sophisticated approaches. And of course, we can model nonlinear trends using like nonlinear transformation, like a log transform or any other transformations, just to transform the data to be linear in another form. Another interesting topic, we won't cover it like fully today, we'll just mention, is the handling multivariate time series. A multivariate time series consists of multiple interdependent variables recorded over time. And unlike univariate,
Interdependent means that they're dependent on each other, right? Let me see. Interdependent variables. The interdependent variable is a variable that is closely connected to and influenced by other variables with a system. Yep, that's correct. I thought about that.
time series where we analyze and forecast a single variable. Multivariate time series involve interactions between multiple variables.
Bro, I love this. Like, if you like 10 years ago, you couldn't search it that fast. You know, you would need to spend a little bit more time searching for it. Now you search it, you get the answer, you're happy, you understand it, you're good to go. It's like, it's so good. Not gonna lie, like we have come very far as a society. I ain't gonna lie. I think AI, like, as it does a lot of negative things, it has also a lot of good things. It's insane, like how efficient you can be, how much more you can understand by using AI, right?
For example, economic indicators like GDP, unemployment rate, and inflation rate, where changes in one influence the other. And sensor reading from the IoT devices, where multiple sensors provide correlated measurements over time. Of course, there are challenges in those modeling, like increased complexity and high computational requirements. But there are models to solve these tasks, and yeah, that's a pretty interesting task to solve, actually. The next interesting task is, let me move a little bit. So yeah, is anomaly detection in time series. Anomaly detection in time series is a crucial task that involves identifying unusual patterns or outliers in the data. And these anomalies can represent critical events or errors that require immediate attention. For example, in financial application, anomalies could indicate fraudulent transactions. And in system monitoring, they might signal hardware failures. And in manufacturing, anomalies can highlight quality control issues. And identifying such deviations early can help prevent larger problems and ensure smooth operations. You can use the simple statistics like z-score or modified z-score or moving average to highlight those values, or you can use more sophisticated approaches like machine learning approaches, like one-class SVMs, autoencoders, isolation forest, just to train a machine learning model that will take a look for the anomalies. As I mentioned during the talk about the Prophet, is the change point detection. The change point detection identifies the moments in time series where the statistical properties such as mean, variance, or trend change significantly. And these points indicate shifts in the process, which could have a real-world implications. For example, in financial market, a change point could indicate a trend reversal in stock prices. In climate data, it might signal a sudden shift in temperature patterns. There are various models, various statistical models to do this task, and you
Miracle Mart refresh? Like, I don't quite get it.
Is there a delay today?
You can use machine learning approaches, you can use like segmentation algorithms, and there are, of course, like domain-specific approaches where you can use your domain knowledge. And this task is particularly interesting if you go into the production, since like this is part of the production monitoring system. Moving to the best practices, just to sum up. The first best practice is proper model validation. Time series data requires validation methods that respect its temporal structure. For example, instead of random cross-validation, you should use time-based cross-validation techniques like rolling or sliding windows. This ensures that the training data always precedes the test data, preventing data leakage. Additionally, it's important to validate the assumptions of the chosen model. For instance, ARIMA models assume stationarity, so you must test it before building the model. And if the assumptions are violated, the model may produce unreliable results. The second one is the importance of domain knowledge. Using domain knowledge is essential for effective time series modeling. Experts can provide insights into the data's processes, which can guide feature engineering and model selection. For example, a retail manager might explain the impact of seasonal promotions, helping you create better features for seasonality. And understanding the context behind the data is also helpful when you interpret the model predictions and when you make informed decisions. Models are tools, but domain expertise ensures the output are used meaningfully. And please monitor and update your models. Time series data is dynamic, and the patterns you model today might change in the future. Continuous monitoring is critical to track how well the model is performing over time. For example, if a sales forecasting model starts showing increased errors, it might indicate a shift in customer behavior or market conditions. And to maintain accuracy, you should periodically retrain models with the new data. And this ensures the models adapt to changes in the underlying patterns and remain relevant for future forecasting. And as for the documentation and reproducibility, keep detailed records of your work, and it is crucial for reproducibility and transparency. Document every step of the process from data preprocessing and feature engineering to model parameters and evaluation metrics, especially data validation and testing, how your model is tested, how the dataset is collected. This not only helps you or others to reproduce the result, but also ensures the analysis can be audited and improved in the future. Reproducibility is especially important in collaborative environments and industries with strict compliance requirements. Okay, let us have a key takeaways. So we discussed what a time series is. It's data collected over time and often shows patterns like trends, seasonality, random changes. And recognizing these patterns is important because it helps us choose the best tools for forecasting. Second, we looked at how time series is different from regular predictions. Time series models understand that past values can affect future ones, while regular prediction models assume each point is independent. This makes time series unique and requires specialized models. We talked about the models you can use. Traditional models like ARIMA and SARIMA work well for trend and repeating patterns. And for more complex data, tools like tree-based models, ensembles, and Prophet can be used, and they are useful actually for dataset with multiple time series. Advanced techniques can also be used to uncover hidden patterns. And we also covered how to prepare and work with time series data. Cleaning the data, fixing missing values, adjusting the trends, and scaling is essential. And adding features like lag values or average over time can make predictions better. And lastly, we discussed best practices. Always test your models properly to avoid errors or overfitting or data leakage. And use your understanding of the data's context to make better predictions. And do not forget to keep your models updated as the new data becomes available. And with these key takeaways in mind, you now have a solid foundation for working with time series. And thank you for your attention. I would like also to mention that I hope that this lecture has given you an understanding of how to approach time series analysis with confidence. We have covered the basics, but the time series topic is deeper. I highly recommend, if you're interested, take a separate course specifically on time series. And remember, forecasting is as much about understanding your data as it is about choosing the right tools. And as you move forward, I encourage you to experiment with the methods we've discussed and explore how they can be adapted to different datasets and challenges. Do not hesitate to review the concepts we covered. Learning and practice go hand in hand. Yeah, I'm here to support your journey, so feel free to reach out to me.
The same, b and d squared. But
It's just like from Dallas, Austin, or Texas, Austin.
I mean, it doesn't look like, I'm seeing this teapot in these boxes, but they kind of look, don't they look a little strange to you? They don't look very natural. It's just, everything is, I mean, it's right maybe. They don't look like this. Oh, this is more like what I see when I look at something.
Wow.
The other one is, I don't know what it is. It's just weird. So that's also
There's something so fun about loot drops in games. I just love the shimmering beam of light letting you know you're about to get something interesting. So I was thinking, what if there was a really cute farming game, but all of the crops are loot drops? I was curious what this would be like, so I decided to try to make it myself. So this is my journey of creating a loot drop based farming game in Godot and everything I learned along the way. The idea I had for the gameplay loop was pretty simple. My plan is just have a plot of land where the player can plant seeds, water them, and then the plants will grow and pop out into these loot drop like.
You know what? Fuck it. We'll be watching it.
There's something so fun about loot drops in games. I just love the shimmering beam of light letting you know you're about to get something interesting. So I was thinking, what if there was a really cute farming game, but all of the crops are loot drops? I was curious what this would be like, so I decided to try to make it myself. So this is my journey of creating a loot drop based farming game in Godot and everything I learned along the way. The idea I had for the gameplay loop was pretty simple. My plan is just have a plot of land where the player can plant seeds, water them, and then the plants will grow and pop out into these loot drop-like plants with different rarities and different sell values, and then you can collect those plants, carry them over to somewhere to sell them, get money, and then use that money to buy upgrades for your tools and farm, and maybe you just win the game when you get all the upgrades or something like that. I want this to be kind of arcadey and fast-paced, so the plants are really quickly growing. I'm thinking about it for an art style inspired by Link's Awakening and Zelda Echoes of Wisdom, where the characters are kind of like toy-like, and you also have a kind of tilt-shift shader going on to make things look more just like a fun, playful toy environment. Start out, I should just make a really simple environment with a basic character, and then we'll get to some 3D modeling and just setting up the environment, I guess. So I spent some time setting up a simple player moving around the scene and a camera with an almost top-down perspective, kind of like Link's Awakening. It's probably a fine starting point. Then I started thinking about how the plots of dirt where you'd plant your seeds would work, and I mocked one up in Godot. So now I modeled an actual dirt plot in Blender, and here I thought about how I'd actually want to do the texturing for all of my models in the game. So I decided to use a method I'd seen before for low poly models, where you can kind of just scale the UVs along a gradient image texture to apply nice colors to your models very quickly. And you can just share the same small image texture for every single model in your game very easily. I decided to go for a pretty shiny look to an actual dirt plot in Blender. And here I thought about how I'd actually want to do the texturing for all of my models in the game. So I decided to use a method I'd seen before for low poly models, where you can kind of just scale the UVs along a gradient image texture to apply nice colors to your models very quickly. And you can just share the same small image texture for every single model in your game very easily. I decided to go for a pretty shiny look to kind of capture a toy-like texture. Then I brought the dirt plot model into Godot and made it its own scene. I mean, I guess this is a fine starting point, right? I decided to do some more 3D modeling, and I knew that I wanted 3 different growth stages for my plant. Seed stage, sapling stage where there's some like green, and then the full crop. So I decided to try to make the seeds model first. I don't know, it's a start. Then I tried to make the sapling. I'm still quite new to 3D modeling and learning as I go, so everything's a little bit more of a struggle than it needs to be. It was like an alien or something. But I eventually got a pretty good looking result for the sapling. Yeah, that actually looks pretty good, right? Then I brought all these models into Godot, and at this point I still wasn't quite sure how to make them all share the same texture, so that wasn't quite working, but they were all in the game. At this point I was feeling like I needed to change the seed model a bit because it was a little bit too close to resembling hot dogs. I think the seeds could use some improvement. But I decided to take a break and come back the next day. I fixed up the seeds a bit to make them look a little bit less hot dog-like. I figured out how to manually assign a shared material to my imported models. If I change this, it should change all of them. But I realized this would be easier if I just had an automatic way to do this. So I ended up writing a post-import script that would automatically assign any imported meshes the new shared material to speed up this pipeline. Okay, that's cool. Then I set out to model my first crop, a strawberry. One interesting thing here with the modeling is that I had to keep in mind the top-down perspective of my game because that actually influences what parts of the model you can see. Like I might do different decisions if I weren't planning from this sort of view angle. And I found that tilting the strawberry a bit looked a bit better. I brought my new strawberry model into the game and my post-import script works so the material was assigned correctly. That's cool. So my import script is working. I'm still kind of going for that plasticky look so that it looks kind of like toy-like. To make things look more toy-like and small, I decided to experiment with the depth of field blurring effect on the camera to kind of capture the tilt shift effect that games like Link's Awakening use for this purpose. If you do it correctly, this effect kind of tricks your brain into thinking it's looking at a miniature scene because it mimics how a camera would capture images of a small object, where if you have the small object focused in the middle of the scene, the areas at the top and bottom around that object would be blurred. I wasn't totally satisfied with the look though, I thought I might change it later. Well, I think we'll definitely improve that blur effect later, but I didn't. Now with this all set up, I wanted to start on the basic gameplay mechanics. I started out by working on the crop scene, which would be the representation of a crop from seed to fully grown. I think I'll want to make this so I can have multiple different types of crops with different properties. So I think to do that, we can use a custom resource that will store that information, and then the crop can pull from it. This can have multiple different types of crops with different properties. So I think to do that, we can use a custom resource that will store that information, and then the crop can pull from it. This resource would contain information like the different meshes for the different stages of the crop's growth, the growth time, the name, etc. And then made it so that if you click on a plot, it will actually plant a seed in that plot. So if I click, aha, seeds. Then I want to make it so that if you clicked on that plot a second time, it would water the seed and then start the growth phase. If I want to visually show watering the crops when you click on it again, I need to change the color of just this one face of my planter mesh, and I'm not entirely sure the best way to do that. Because right now, basically what's happening is all of these plots are sharing the same material because that's efficient to do. But that also means when I actually update the color of the material, it updates all of the different plots because they're all sharing that same shader material. So I did some research and I learned about per instance shader uniforms. Per instance uniforms, that sounds like what I want here. They let you modify specific parameters for each node using the material because they are set on a geometry instance level rather than a material level. So I set up a shader material with this, and then I wrote some tween code to update the color of the dirt over time once watered, and it worked. Oh, okay. Obviously, don't want to turn black, but I guess this is kind of working. Now we need to make the plants grow. Then I implemented really basic crop growth after the seed is watered. So you plant seeds, you water it will turn into a sprout and then turn into a full strawberry. Need some animations and effects and things. I'm excited to work on that tomorrow. I think this is pretty good progress for today. I want to make things feel a bit more juicy and fun, so I set up to try to make some animations for the crop growth. I spent some time researching and testing different animation easing and transition curves. I set up tweens to animate the growth of the sprouts, and I spent some time researching and testing different animation easing and transition curves. I set up tweens to make some animations for the crop growth. I spent some time researching and testing different animation easing and transition curves. I set up tweens to animate the growth of the sprouts and then the crop popping out once it's ready. I mean, this looks pretty good, right? And now if I add different crops, I can just make different crop data instances with different meshes and different times, and it'll kind of all work just dynamically, which is pretty cool. Then I experimented with an infinite tween-based animation once the crop is ready and waiting to be picked up, where it kind of scales in and out. And that looks pretty good, right? I would like the transition between sprout and the strawberry, maybe like a little puff of smoke or something, like a particle thing would do it. I set up a particle system for a little explosion effect that would play once the sprout stage was finishing. That's kind of good, actually, something like that to hide the transition. And I really like how that looked. It made the transition a lot less harsh. I then added a little pop sound. That's kind of good, actually. Of smoke or something, like a particle thing would do it. I set up a particle system for a little explosion effect that would play once the sprout stage was finishing. That's kind of good, actually, something like that to hide the transition. And I really like how that looked. It made the transition a lot less harsh. I then added a little pop sound when the crop has finished growing. I also briefly tried adding in an effect while the sapling is growing bigger, but decided that was too much. As fun as that is, I think that's too much. Now I really want to move forward with implementing a basic gameplay loop. I guess the most basic.
It's not too much. I think it's just the sound choice. The sound design of that was a bit too creepy. I think if she tried to go for a little bit of a faster, like, you know, the important part about like video game sound design is that it needs to sound satisfying. So it just needs to sound satisfying. That's the most important thing.
That I can implement is just the ability to pick up the crops once they have grown and then somehow sell them to make money, and then I can flesh that out more after. To get started on this, I realized I needed a way to determine if the player is actually close enough to something to interact with it. My initial idea for how to do this was to add an area around the player and then areas to each interactable object, and then hook up signals to detect when the player is within the area of an interactable object and change whether that object can be interacted with or not based on that. I got this working for only allowing you to actually interact and plant seeds in plots that were near the player, but I realized that I need to duplicate a lot of this logic. I might refactor this tomorrow into like a component because I actually want to do this at least for the selling bin as well. But I decided to leave it as was for the day. I then wanted to make it so that you could actually tell which plots you can interact with on hover, just so you know. Like here, it looks like I could click it, but I can't. And I'd like to be able to tell that without these collision shapes on. To do this, I first tried changing the color of the plots, but I didn't love how that looked. So I decided to do a different approach and just show or hide a mesh based on your mouse and where you are. Okay, so I think this is working now. Still no gameplay, but maybe tomorrow. I decided to go ahead with implementing a player interaction area component to handle checking whether objects can be interacted with based on whether the player is close by. So basically this is an area that can only be interacted with if the player is in the area. Then I want to dispatch signals from this component that the parent component, the plots or the crop, can listen to and then act on. So I hook this up to the plots and the crops as well. See if it's actually working. All right, I'm glad I did this. I think this will make things quite a bit easier and a lot less complex code-wise in the end. Now we can implement interaction with the crops. Then I decided to use this new functionality to add a hover state to the strawberry crops to indicate that you can pick them up. Again, I was able to use the per instance shader method to modify the emission of the material on the strawberry crops to kind of make them glow as you hover over them. I then made it so that the hover highlight tweens in rather than just going straight to highlighted to make it look a bit more smooth. Now I decided it was finally time to actually implement that basic gameplay loop I had been trying to do for a few days. I think what we need to be able to do now is actually pick out the fruit and bring it to a deposit box and then get money. I guess let's start by making it so you can pick up the crops. So I started out by implementing the functionality to add a top mesh to the player's scene when they click on the crop to pick it up. Now when I pick it up, it should be like on top of their head. I then decided it would be good to have a global inventory autoload script that would keep track of everything the player's carrying. That way I'd be able to tell anywhere in the project's code if the player has enough space in their inventory to carry a new crop. I was also planning to eventually add a basket mechanic where they'd be able to carry more than one crop at a time, so this felt like good legwork to set that up. So let me pick up the first one, but it does not let me pick up the next one, so you can only hold one. So I guess that's working. Then I needed to add a way to actually sell the crops you picked up. For now I added just a really simple box object to the scene that you go to sell your crops. This game is pretty easy to get set up because I was just able to reuse my player interaction area component to detect if you're close enough to the sell box to sell your crops. So pick up the strawberry, we go to the box, we click on it, it sells it, and I now have $10. So I guess that's working. And every time I sell it should increase my money that's printed out here. I have $20, $30, okay. And then I set up some UI to display the player's money in game. Grab one and sell it. Oh look, we have $10, so I guess we have a game now. I got started a bit late this day, so I decided it'd be fun to just do some 3D modeling and get more different crops into the game. I made some concept art for some different plants and fruits I might include. So then I modeled and textured a blueberry, a watermelon, orange, corn, carrots, and they're looking pretty decent. Right now we have strawberry, blueberry, carrots, corn, orange, watermelon. Might press around the scale of these, but in there. And then I worked on modeling the crop deposit box. Yeah, I think that looks fine for now as well. I'm happy with the results. We'll see how they look tomorrow in the game. Now for every plant I have in Blender, I need to make a new crop data type with information about that crop, and then we can incorporate them into the game. This was easy to do since I had already set up this whole system to account for different types of crops. I mean, they look decent, just some are a little bit bigger than others. But, you know, we can also bring in the crop deposit box. I mean, that looks better, right? I realized for the different crops, it'd be convenient if I could just use the same seeds and just tint them different colors. So I made a grayscale version of the seed. For the time being, I set it up so that when you plant a seed, it's just a random one from all the possible types of crops. All right, so we're getting different colors here, and they should grow into different crops. That's pretty cool, right? Then you can pick it up and sell it. Wow, 100 money. The ones are all worth 10, except the watermelon, which is worth 100 right now. It takes takes longer to grow. I feel like the corn is way too big, or the strawberry is too small now. Something needs to change in terms of scale. I did a little bit of modeling adjustments to make things look more properly scaled, and things are looking pretty good. All right, I think this is working, right? Like how they just go on top of your head like that, like the watermelon. Now I decided it was finally time to work on the main mechanic that had inspired me to make this game in the first place, the loot drops. Maybe I will just try to actually do some sort of rarity system and make some sort of loot drop particle effect for each different rarity, because I think that would be fun. The plan was that there would be 4 different rarities: common, rare, epic, and legendary. Each rarity would have a corresponding drop chance, and as the rarity level of a crop goes up, its sell price would also go up. So I think common will have no particle effect, rare will have a particle effect, epic will have one, and legendary obviously will have one as well. So I set up some initial base prices for crops based on their growth times. So I think when the plant gets watered, we should choose its rarity, because I plan to eventually make it so that there is a watering can with upgrades that would increase your chance of getting higher rarity crops. For determining which rarity is chosen when you water a crop, Godot actually has a really convenient method called rand weighted, which takes an array of weights and returns an index based on those weights. So I set that up to correspond to each rarity type. So this should be 65% common, 20% rare, 10% epic, and 5% legendary, and wrote some code to determine the rarity of the crop when it's watered. Then I also set up rarity multipliers for increasing the sell price of crops based on the rarity. All right, so I think this is working now. So these ones are common. If I sell it, it says it's common. This one's rare, and it's rare. So now I guess we can actually implement of the crop when it's watered. Then I also set up rarity multipliers for increasing the sell price of crops based on the rarity. All right, so I think this is working now. So these ones are common. If I sell it, it says it's common. This one's rare, and it's rare. So now I guess we can actually implement the particle effects for these different loot drops. I think that will be fun. This is really what inspired the whole project, so I was excited about this. First, we can probably just do like a beam of light coming out of it that maybe flickers. I first tried doing this just using a mesh instance with the particle texture and making it glow, and I tried animating that color to make it look like it was flickering, but this didn't really feel quite as dynamic as I wanted. That's not great. I want to scroll the texture too or something. So it's been a while thinking about how to do that seamlessly, and I was thinking maybe I could make the texture loop and then animate the UV values to make it scroll, and I tried experimenting with this, but I couldn't really get it looking like I wanted. Then I realized it might actually just be easier to do this using a particle system. I wonder if this would actually be better to use a particle system, because I was almost effectively trying to implement that myself. So I switched to experimenting with that and tweaking settings, and it was looking much better. That looks decent, right? Then I decided it would look cool if there was another effect kind of around the base of the crop. And this was actually really easy to implement. All I had to do was apply a texture to a quad mesh and then just animate the rotation of the mesh to make it spin. Then I set it up so that the color of the particle system would change to match the rarity level of the crop when it's instantiated. Then I set it up so that this effect would actually spawn in on crops based on their rarity when they are fully grown. This is good progress, right? We got some loot drop mechanics going on. I maybe should make the rare a little bit less crazy and then maybe save some of the effects for just the epic and legendary. So like maybe rare wouldn't have the circle, maybe epic has the circle, maybe legendary has something else as well, but we can play around with that tomorrow, I think. I spent a little bit of time just tweaking the particle effects to see if I could make them look any better. I basically ended up keeping them the same, but I added some proximity fade to make the beams more smoothly transition into the 3D models, and I also scaled up the spinning circle effect just for the watermelon. Should I make the legendary one have more particles? That's exactly what I want. I ended up settling on adding some glowing star particles around the legendary drops. Sparkles for the legendaries makes them feel a little bit more impactful. Then I decided to remove the circle effect from the rares so that the effect would actually escalate for each level. We'll leave it like this. I think these are pretty fun effects. I think we can move on to the next thing now, which I'm not sure what that is. I knew there were a lot of things left to do at this point, but I decided to start out by just improving the crop selling experience. I made it so that when you walk near the crop deposit box, the lid animates open, and when you hover over it, a highlight is added, like with the pickable crops, to indicate that you can interact with it. I also made the box squash and stretch with a tween-based animation to make it feel more fun. I ran into some issues getting this configured correctly. Okay. But I eventually got something looking decent. I then changed out the font for the money label and wrote some tween code to animate its value as it changes to make things more satisfying. I'm happy with how it looks aesthetically right now. I feel like it's pretty fun. But yeah, I'm not trying to make it into an actual game from this point. What if we use that I could maybe implement some sort of combo system that asks you to deposit certain crops in a row, like 2 corn, 1 strawberry, and 1 orange, and you get like 100 times bonus. So that will give you some reason to plant certain crops over others, and it could also have some sort of timer on it so it expires and you have to do things quickly. So to implement this idea, I need to do a couple of things. For one, I actually need some sort of inventory system so you can actually choose which seeds you're planting. Obviously, I need some sort of shop system to buy specific seeds, and I also might want to implement the basket thing I've been talking about, where you collect multiple fruits at once. So I decided to start out by just implementing the inventory UI for seeds. I haven't done an inventory UI before, but I'm thinking it will just look kind of like the Minecraft one with the hotbar at the bottom. We don't need a full inventory for this because we only have like 6 seeds, so probably just 6 slots or maybe 8 slots if we have tools, and then you can switch between them and click on them to choose the seed you actively have selected. So I started mocking out this hotbar UI. For setting up the icons for the UI, I decided I would use a viewport to display the 3D model I wanted as the icon, and then just display that in a 2D texture in the hotbar. This is kind of a cool system because it allows you to put whatever you want in that viewport and use it as an icon, and you can update it whenever you want. All right, getting somewhere here. By the end of the day, I had it so I would display all of the seeds that were in the player's inventory and the number of seeds as well, but there wasn't actually any functionality yet. So now I should have the correct numbers now. And we're making some progress here, but I think maybe at this point I should just come back and finish this inventory system up tomorrow because I feel like I'm making things pretty messy right now, so probably better come back. I wasn't totally satisfied with how I was setting up this inventory and inventory UI structure, so I did some thinking and just diagramming to figure out the best way forward. I've been taking some notes on what's going on, and I think I might be overcomplicating things, but maybe that's fine for now. We have a lot of different classes going on here for different parts of the inventory, and yeah, let's just get this working. Figuring out how all the data should be stored and reflected in the UI and then sent to the player was a bit tricky, and I eventually got something working. I wasn't still 100% satisfied with it, but I felt like it was fine enough for this project. Okay, kind of working, right? So I might pick that. Okay, just planting blueberry seeds, pick that. Planting carrots, pick that. Planting strawberries. All right, I think we almost have this working. Now I want to think about how to add in a watering can and also a basket that will allow you to pick up multiple crops at once. I spent some time modeling a basket and then a watering can in Blender, and then I brought them into the game. All right, so that looks pretty good, right? It looks like a watering can, and we also have this basket. So I'm excited to try to actually implement these now into the toolbar, but it's getting a bit late now, so I think that's where I'll leave it for today, but we made some good progress. Now what I should do is actually implement these two tools, the watering can and the basket. I kind of written this inventory code as if you could only carry seeds, so I need to think about how to refactor that. I first had to spend some time refactoring the inventory UI code to be able to handle tools as well as seeds. All right, that's good. It's time to get these tools hooked up so that it doesn't crash when I click on them. We can cut them spawning here. Then I made it so that you can only actually water crops if you have the watering can equipped. So if we plant the seeds here, we can water them if we have the watering can equipped, but we can't if we have something else equipped. It's going to feel more like a real game, I guess, other than the watering can being located inside your body right now. And then position the watering can and basket models in the player scene, positioned as I wanted them to show up. Then I can just hide or show them based on whether the tool was equipped. So then I started working on the basket implementation. Basically what's going to happen is that if you have space in the basket, which can be upgraded, but let's say start out you have 4 spaces, you can pick up a fruit and it'll go into the basket instead of just like onto your head like that. And then when you click on the deposit box with a basket equipped, it will deposit all of the fruits in your basket instead of just one. And then we can do a combo system based on that to make things more interesting. I decided to keep the logic here just within the inventory code because it's basically just an extension of the inventory. I got the basic logic for this working. 1, 2, 3, 4. Okay, we sell them. I think this is working. And then I started thinking about how to actually update the visual of the basket to indicate what it's holding. I made the basket its own scene so that I could add logic to it and have it listen to signals from the inventory when it's updated. So I think to place the different crops in the basket if I want to make it visual, I might want to think about how to subdivide the basket area into different shapes based on the number of crops and kind of have that work dynamically. So I think this will be a little bit tricky to figure out, so maybe I'll just do it tomorrow. I wrote some code to position and scale the relevant crop models within the basket so that they would all fit within a rectangular surface placed inside the top of the basket. For this I just used a plain mesh and that would give me information on where I could actually place things. I started out with just getting all the crops to fit in one row within the basket. I guess it's working. I should probably have multiple rows instead of just one row, and that might make it look a little bit better too. Then I refactored the code to adding columns as well to give the crops more space, and yeah, this took a while, but I really like how it looks. All right, that seems to be working. Then I experimented with some different animations for the crops entering the basket. All right, I think it looks pretty good. And then I decided to actually add in the rarity effects as well to the crops that you're carrying, so you know exactly what you're holding. This game is getting pretty polished for not really having much gameplay. I realized it would be nice if the basket icon in the inventory actually reflected the crops you were holding. Since all of the icons in the toolbar are actually just 2D representations of a 3D scene, I was actually able to just create another instance of the basket scene, and since it would listen to events from the inventory, like the one on the player's head did, it would just automatically update. That's kind of cool, isn't it? You can see them going in. Then I spent some time just looking for and adding a bunch of sound effects. I added one for when you deposit crops and the money goes up, for the crop box lid opening, for planting, picking, and watering crops. I set up some tooltips on the hotbar to tell you what you're actually hovering over. Then I finally started working on a seed shop UI so that you can actually buy more seeds once you run out. Kind of thinking, you know, just like some simple UI like this, and maybe some little tiny shopkeepers that are cute that you just click on and then it'll bring up the shop menus. I spent some time mocking up a UI until I figured out something I liked. I mean, that's not terrible looking, right? We just need to actually make it work. Then I worked on adding the functionality to actually add seeds to your inventory as you buy them. If you buy corn, oh, look at that. It's working. And also subtract money and also only let you actually buy seeds if you have enough money. Once I got that working, I went into Blender and tried modeling a shopkeeper. Then I modeled a little wooden sign that the shopkeeper could have next to them to indicate what they're selling. I added this into the game and positioned a flattened seed model on the sign. It made it so that when you click on the shopkeeper, it opens up the seed shop, and the shopkeeper also tweens in size and hover to indicate interaction. That's good for today. I was feeling like I really needed to set an actual deadline for this project, otherwise I would just keep working on it forever. It's always so hard to know when to say the project is done because obviously it's not a full game and I'm only spending a couple of weeks on the project. But for me, this is about the learning experience of making something new and figuring out different parts of making a game. So I think we're almost there. The plan now is to spend the next 3 days, including today, just finishing up this project, and we'll just call it then wherever it is, hopefully. I had a big list of things I still wanted to implement before that point. I decided to start by actually trying to implement that bonus system I had thought about earlier because I thought it would make it feel more like a real game with actual decisions to make and goals to aim for. My thought is that I can kind of just add a sign that's next to the deposit box that will have the current combo on it, which would just be like 2 carrots, 1 blueberry. And if you deposit a basket with that exact combo in it, you'll get the amount it would normally sell for multiplied by some combo bonus amount. And as you upgrade your basket and can carry more things, there can be more things in the combo, and that will increase the multiplier even more. So you can get really crazy huge numbers from doing this. So I modified the shopkeeper sign to use for the bonus. Then I wrote some code to pick random crops up to the max number the player can currently carry in their basket as the current bonus, and then display the models for those crops below the sign. Okay, so I think this is working. We'll just put 2 random crops on the sign. Obviously, we need to get them on the surface of the sign instead, but that's a good start. Let's think about how to display these on the sign. I ended up implementing a very similar system to how the basket was working to dynamically arrange the crops on the sign depending on how many there are. I had some issues here figuring out why certain crops weren't positioning on the sign correctly. I don't know why it's so low. Why is y negative 0.75? And I eventually realized it was due to an incorrect origin point set in Blender for the mesh. So the problem was I didn't have the origin set correctly in Blender. Then I made it so that if you fulfill the bonus, it gives you a large multiplier on the crops you're depositing, and decided to make the bonus multiplier depend on the number of crops that are required. So now it should show what the actual bonus is here, which depends on the number of things. I then realized it would be more interesting if there was actually a timer on the bonus. I think I want a timer, because otherwise you can just take your sweet time doing this, which doesn't feel right. So I implemented that, and with all of this, it was definitely starting to feel more like a real game. All right, so I think this makes it feel more like a game. I don't know, there's so many things I could add to this. There's like a never-ending list of things I could add, but I'm going to have to end it somewhere with this. So let's make maybe the upgrade UI so that I can upgrade the basket and the watering can. The watering can will make it more likely to get rares and legendaries and epics, and the basket will just make it so that you can get more items in your basket. Probably start out with 2 and then go up from there. Then I started mocking up the upgrade UI for tool upgrades. All right, just getting this basically set up, but I'm feeling a bit tired suddenly. So I'm kind of thinking maybe I should come back to this tomorrow. I was realizing that there's actually some strategy in the game now, which I was happy to feel. I continue working on the upgrade UI. So we need the tool icon, maybe just like we have the upgrade level and then like a upgrade button with a cost. I decided it was fun for the icons for the tools to actually make them spin around in the icon because I could do that with the way things were set up. So I did that. For the watering can, I wanted the upgrades to increase the chances of getting rarer crops. So set up different rarity weights for all the possible levels of the watering can. We'll tweak these percentages, but basically this will make it so that when you upgrade, you'll just get higher and higher chances of getting rares, epics, and legendaries instead of commons. And at the highest level, you'll get 0 commons. So that should be fun. When we fully upgraded the watering can, it was fun to see how every single drop would be glowing. And then made it so that basket upgrades would increase the number of crops you can carry. I added the shop to the game just by copying the other seed shopkeeper for now. Okay, I'm just going to make these different, but now this opens the upgrades, this opens the seed shop, and then set out to model a player character. I'm trying to think of something that kind of could stay in the spirit of the current character, meaning just like a cylinder. And I was really like a meerkat could do that. So maybe we can really simplify just like tubular meerkat. Like look at that. It's just like a little tube. This modeling was quite a struggle. I feel like this is turning more into a like mole, but that's fine. So we have a mouse, meerkat, mole. If you look underneath, there's secretly a smile. But I came up with something and I brought it into Godot. I also tweaked the seed shopkeeper a little bit to try to make it more cute, but I'm not sure I succeeded. And then modified that shopkeeper to make a slightly different looking other shopkeeper for the upgrade shop and brought that into the game and changed the sign as well. So you can just like leave and I think eventually fall off the map. What happens if you do that? Goodbye. I could add a fence around the game or I could just leave that in. If you choose to jump off the map, maybe that's your fault. But you know, this is pretty cute, right? I wish I was a little bit better at character modeling though, but that will come with practice. My goal was for this to be the final day of development. All right, so we have a bunch of things to do, but we do have pretty much a full game now here. I first decided I wanted to actually animate the player character to make it look a bit more fun as it moved. I ran into some bugs getting this rotation working correctly. It's like it's ice skating. But I eventually got it working. I felt that now that you can see the back of the character, it really felt like it needed a tail. Maybe it needs a tail, actually, since you can turn around. So I spent way too long trying to model a tail for the character in Blender. I don't know if the tail is good, and I spent like an hour making this tail, but I guess we can leave it. I also spent some time getting the character to turn smoothly instead of just snapping to the new direction. I made it.
Oh my god, imagine if she had those what are those called? The newest thing they added to Godot where like you can have motion. Is that a tail? It's fuck, what is it called? Like motion blocks? I don't fucking know, but it's like when you make a move, it kind of follows the character, but it's also like following the character. Holy shit, what am I saying?
So that the character moves up slightly in the Y direction when it walks over the plots so that it doesn't clip through them as much. I then added a squash and stretch animation on the character and made it play when the character is moving. And I added a slower, less exaggerated version of this for just an idle animation. I also adjusted some environmental lighting settings to make things look a bit better. I noticed that with my scaling-based animations, the specular lighting highlights had an annoying jumping effect and I wasn't sure how to fix it. Like, why are the lighting calculations changing so much? Interesting, so without the specular reflections, things actually look better. I'm guessing the problem is I need to actually animate the rig of models instead of actually animating the scale of the mesh non-uniformly, because I'm assuming that's affecting the normal calculations and lighting and making things weird, but this is a lot quicker to get working for right now, so I guess I'll just leave it and I can fix it sometime in the future. Then I was playing the game and I realized it was basically impossible to fulfill the larger bonuses once you have your basket upgraded. To grow that many things, even if we have all the seeds, definitely need more time. So I needed to address that. So I made the bonus timer scale based on the number of crops required. I guess we should add an end goal maybe and just like have you win the game. My thought is that you just win the game when you've upgraded everything and also you have 100,000 money. Maybe we can just set that up and have kind of like an explosion at the end or something when you win and some text that shows up in the UI. So I set it up so that I would tell the player the goal when you start the game. And I wanted to add a celebratory effect when you actually complete the goals. So I set up a particle system that's kind of like confetti that would explode when you complete the goals and also some congratulatory text. And I also added a celebratory sound effect. So now was the end of the day and I knew it was supposed to be my final day. I am so close to getting this to a done state, but it's getting kind of late. So I think I'll just go back tomorrow morning to add a couple small finishing touches, a couple more sound effects, maybe some like bushes around the edges or something like that. And then we'll be done because I need to start the next project. So the plan for today is to actually finish up this project and call it done by the end of the day. So I'm just playing through the game and I'm realizing one thing that's tricky is once you get to these higher levels and you need to fill these bonuses, it's actually hard to keep track of what you've already picked up. I could maybe like change the colors of things on the signs based on what they picked up. I wrote some code to just change the emission color of the crops on the sign as they are picked up to let you know that they're already in your basket. This worked pretty well. Then I spent a while just finding and adding some more sound effects for purchasing seeds, upgrading tools, and also when you click on a crop to pick it up, but your basket's already full so you can't. I briefly considered here trying to write a guitar soundtrack for the game before realizing here that I really only know how to write metal music, so that didn't really feel fitting.
God, she writes with metal music. That's amazing.
Here trying to write a guitar soundtrack for the game before realizing here that I really only know how to write metal music, so that didn't really feel fitting. I don't know if I can really write an ambient farming soundtrack. I just want to finish this today, so we'll save the writing music for another project. Really feel fitting. I don't know if I can really write an ambient farming soundtrack. I want to finish this today, so we'll save the writing music for another project. I then added a walking sound for when the player is moving, and I also added some particles that spawn as the player walks to indicate some dirt getting kicked up. Okay, this is fine. That wasn't even on my list of things to do. It's very easy to keep adding things to games. I made this ground plane like forever ago. What does this even look like? Is that better with a brighter color? Does it seem a little more vibrant this way? Probably good. I added a special sound effect for when a legendary crop spawns, which makes it feel a lot more satisfying. Okay, that's kind of fun. I'm glad I added that. Look at how many rares there are. It is fun once you get all the upgrades. At this point, I feel like the scene was looking a little boring though outside of your crops, so I decided it'd be good if I modeled some decoration. I modeled some grass and trees to place around the scene scene. I spent a while arranging these models in the scene and rotating and scaling them for variety as I placed them. But this things were really coming together. Yeah, you know, this is looking good. I like this. This is really cute. It really feels like kind of an actual game now. So one last idea I had was to actually show you at the end how long it took you to become the best farmer. So let me just see if I can implement that really fast. So I set it up and set it so it would display in the final congratulatory text. So I think the main thing left to do here is actually just balance the game, which I'm not really sure how to do. Congratulatory text. So I think the main thing left to do here is actually just balance the game, which I'm not really sure how to do. I think I should make the upgrade for the watering can a little bit more powerful, because right now it's not that noticeable. So I spent a bit tweaking these drop rates to make the upgrades feel a lot more impactful. Let me just play through it one more time and see how it feels, but I think this is it, finally. And then I played through the whole game one more time to test it out. Okay. That only took me 6 minutes, so I guess that's my new record. If you play the game, let me know what your time is. And then I finally decided that I was done. So I think I'm done. This is probably my most complete game so far, I guess, other than maybe my game jam game I did in the fall. This is like a full experience, and I can totally see this turning into an actual game. So I'm quite happy with this, and I learned a lot. I definitely thought this was going to be a short project, but of course it was a lot longer than I was expecting. I can never really keep things short, but yeah, I'm pretty happy with this. I hope you like it as well. So this is the final game, and I am quite happy with how it turned out. I spent quite a bit of time on this project, a lot more than I was initially thinking, which is kind of what always happens. But if I had more time, there's still obviously a lot more I would add to this to make it more of a real full game, but I think it is fun as it is, as well as a little demo of this idea. I'm particularly happy with the visual aesthetic of the game. I think it's really cute and fun, and I also really love the loot drop effects I implemented as well. If you'd like to try out the game yourself, I have it up on itch.io, and it's linked in the description. Let me know in the comments how long it takes you to become the best farmer. Also, if you're interested in supporting the channel and you'd also like access to the source code and assets I made for this game and all of my past projects as well, I have a Patreon page I'll have linked in the description. Thank you so much to everyone who's already been supporting me over there. I really appreciate it. Thank you all so much for watching, and I'll see you in the next video.
Hello, everybody, and welcome to this session on exploratory data analysis, or EDA. I am Dr. Andrei Holz, and I would like to share with you insights from years of research and practice in machine learning and data science. This is the first lecture in machine learning lectures, and EDA is an essential step that not only helps you understand your data, but also guides every subsequent decision in your data projects, whether you're cleaning, if you have any questions, and let us data, engineering features, or choosing models. A robust EDA process is the key to success. And let us move on. What about the agenda? So today's lecture is structured into several major parts. We will start with an introduction to EDA. Next, we will cover basic analytics and how to deal with different types of data. Then I'll show you how automation tools can streamline your workflow. We will also explore visualization tools and techniques. And finally, we will discuss common challenges in EDA and how to overcome them. This journey is designed not only to build your technical skills, but also to show you why EDA is critical and help you avoid pitfalls later in your machine learning projects. Before we get into the specifics of EDA, it is important to understand its role within the broader data analytics pipeline, like CRISP-DM or CRAS, industry standard process for data mining. It provides a structured approach from understanding the business problem through data preparation and modeling to evaluation and deployment. And this is a cyclic process, and that's basically an industry standard in some cases, in some companies, in some industries. So I highly recommend taking a look at it. You can have some information on the link below here. And this is one of the best methodologies to deal with the data. Of course, there are other methodologies, but if you're starting from scratch, I believe it's worth taking a look. And what about the EDA? So EDA is a part of the data understanding phase. There's a lot of phases, and you can take a look at them here. But by following those phases, you ensure that every step you take is both systematic and aligned with your project goals. So again, as I said, review the links, and this slide will also help you to understand the framework, but let us focus on the data understanding and EDA. So what is EDA? Let's find out. EDA, or exploratory data analysis, is the process of diving into a dataset to understand its structure, identify patterns, and detect anomalies. And this is the first step in any data analytics project, performed before any formal modeling or hypothesis testing. The goal is simple: to turn raw data into insights by using summary statistics and visualizations. This fundamental understanding helps you guide every decision you make later. So again, before doing any modeling, before everything, you need to take a look at the data and understand whether this data makes sense, what this data represents, and what are the statistics, what are some maybe insights you can get from this data. And this will be the foundation of your next hypothesis, of your next analysis, and of the models that come after this. So EDA serves as the bridge between raw, unstructured data and actionable conclusions. By performing descriptive analysis, adjusting variable types, treating missing data, and identifying outliers, you create a clear picture of your dataset. This process not only uncovers hidden relationships, but also guides you in refining your approach for feature engineering and model selection. In essence, EDA is what transforms disorganized data into a compelling narrative that informs your entire analytic process. And what about the objectives? Yeah? Let's break down the key objectives of EDA. First one, understanding the data structure. It helps you see how variables interact. Then it's spotting patterns and relationships. It is essential for uncovering trends or clusters. Identifying outliers is critical, as these can skew your analytics if left unchecked. Assessing data distribution, whether it's normal, skewed, or multimodal, informs your choice of statistical methods. Moreover, EDA guides feature engineering by highlighting which variables may need transformational scaling. And handling missing data early prevents future errors, and by reducing the risk of incorrect assumptions, you can select the right model for your predictive task. And each of these elements is vital for building a robust analytical pipeline. Let us talk a little bit about data types and basic analytics. Data comes in different forms, and the first step in EDA is to recognize these types. Data can be broadly categorized into several types: numerical, categorical, ordinal, and time series. So
Numerical text data time series.
numerical data includes continuous and discrete variables, while categorical data uses labels like gender or color. And the example of numerical continuous values like price or like liters of gasoline. Ordinal data has an order, such as ratings, like movie ratings from 1 to 5. Time series data is collected over time and requires special handling due to trends and seasonality. Imagine something like stock price. And recognizing these types ensures that you apply the right statistical tools and visualizations and models for accurate analysis and for accurate modeling. For example, for numerical data, we use summary statistics such as mean, median, and standard deviation. For categorical data, counts, proportions are more relevant. The initial analysis lays the groundwork for everything else that follows. So what about the key statistics? Key statistical measures in EDA for numerical data. The mean gives you the average value. The median provides the middle value when the data is sorted, and the mode represents the most frequent occurring value. And they are called measures of central tendency. Measures of data spread. To understand variability, we use standard deviation and variance, which tell us how much the data deviates from the mean. And as for the indicators of distribution shape, we use skewness that informs us about the asymmetry of the distribution, and kurtosis that measures how heavy the tails are. And they are essential for spotting potential outliers. And together, these metrics provide a comprehensive summary of the feature's behavior. So, in an ideal scenario, a dataset exhibits zero skewness, meaning that the mean, median, and mode are all equal. This condition is characteristic of a perfectly symmetrical distribution, often approximated by the normal distribution. When these measures diverge, it signals that the data might be skewed, which could have implications for statistical tests and model performance. Recognizing this can give you the idea to apply transformations or choose alternative methods to ensure accurate analysis. Not all datasets, not all features are perfectly symmetrical. In many real-world scenarios, you encounter skewed data, And positive skewness occurs when the tail on the right side is longer, with the mode being the lowest, followed by the mean, and then followed by the median, and then the mean. On the other hand, negative skewness indicates a longer left tail, with the mean being the smallest value. Understanding these differences is crucial because the skewness of your data can affect the performance of statistical tests and predictive models, and often transformations are necessary to achieve a more normal distribution. Kurtosis means the tailedness of a distribution. Its names come from the Greek word of curved, and there are three types of kurtosis. Mesokurtic distributions, which are close to normal, leptokurtic distributions, which exhibit a sharp peak and heavy tails indicating a high likelihood of extreme outliers, and platykurtic distributions, which have a flattened peak and light tails. And knowing the kurtosis of your data can alert you to potential risks of extreme values, which is especially important in fields like finance or risk management. Let us take a look at the illustration of kurtosis. And as I mentioned, the leptokurtic with heavy tails, mesokurtic, and platykurtic with light tails. Okay, so when it comes to calculating the statistics, modern data analysis relies heavily on tools like pandas, numpy, and scipy. Each of these libs offer functions to compute means, median, variance, and more, often with options for bias correction. And understanding how these tools work and the assumptions they make is crucial for ensuring that you computed statistics accurately and that the statistics you calculated reflect your data. Of course, if you have some requirements that maybe you cannot use those libs, you can write your own custom functions and calculate the statistics. But please keep in mind that you need to understand all the assumptions and you need to understand what exactly you are calculating. Central tendency metrics like mean, median, and mode are fundamental in summarizing your data. Again, as I said, you can either use something from pandas or you can calculate them on your own. They will return the same result. Again, keep in mind that knowing which measures to use and why is essential for correctly interpreting your data center and making decisions based on it. Variance and standard deviation can be calculated either with one function from pandas or by creating your own function and calculating it. A low standard deviation indicates that the data points tend to cluster around the mean, whereas a high standard deviation signals more spread out values. This insight is critical as it informs how much trust you can place in your average values and how you might need to adjust your models to account for variability. Skewness and kurtosis go beyond basic measures and they help us understand the overall shape of the data distribution, as I said. When it comes to write statistical tests or deciding whether transformation is needed, please calculate the statistics. Keep in mind that if you calculate the kurtosis, there are several options to calculate it, and sometimes the version is biased. So it is important to note that the methods to calculate statistical measures can introduce bias. For instance, many functions include an option for bias correction, and ignoring these can lead to underestimated variances or incorrect inferences about the data distribution. Always check whether your calculation method accounts for bias. This attention to detail ensures reliability and accuracy of your analysis. As in this example, you can review it and you can even try it. And Fisher's definition of kurtosis adjusts the raw value by subtracting 3, which sets the kurtosis of a normal distribution to 0. This adjustment simplifies comparison between your dataset and the normal distribution. It helps highlight whether your data has heavy or light tails relative to what's expected in a typical bell curve. And this is useful in ensuring that any deviation from normality is subject to investigation. When working with categorical data, the approach differs slightly. You look at frequency counts to see how often each category appears. You calculate proportions to understand their relative frequency and identify the mode as the most common category. Additionally, tracking the unique count gives you insights into diversity, and understanding missing values is crucial to avoid skewed conclusions. These metrics provide a clear, concise picture of how your categories are distributed. And now, let us have some coding practice. Welcome to this demo, and we will start with reviewing the dataset. First of all, we will need to connect to Google Drive to access the dataset, then import the libs that we'll be using. I'll be using pandas, numpy, scipy, and some other. And we'll load the dataset and get the descriptions of this dataset since they're available as a separate, let's say, document. And this dataset contains information about households sold in Ames, Iowa, including various numerical and categorical features that describe properties and their characteristics. We begin by connecting to Google Drive and we ensure that we can access it, and we then load the dataset into pandas data frame. We'll load it as a pandas data frame, treating NA or treating missing values as NA. This is important because handling missing values data effectively can significantly impact analysis accuracy. And let us just inspect the first 10 rows. So we have some ID, and some data. Basically, we have some data. Sale price here, sale condition, sale type, and whatever. We can use this method to show elements of the first row, this one, as a dictionary, to review it in a way. But again, let's move to the dataset, and we use df.info to get the basic info about the dataset. Here we have like the number of non-nulls and the data type, the estimated data type, and the column name. So we have 2,930 entries, and like the memory usage of the whole dataset. And we can have the statistics here by using data frame describe. It provides summary statistics, allowing us to spot some basic information about the dataset. However, if you take a look, that's numerical data. We can again show the statistics for one field, but what if we would like to get the information about the, let's say, object data, or I mean, if the data is categorical and we would like to see some categorical statistics, yeah, like count, like number of uniques, frequencies, and so on. We can do this, and here we can calculate the number of unique values for some, let's say, fields here, and we can use descriptive statistics of numerical value, also like this, and we can calculate descriptive statistics of numerical values for all of them, or calculate it for other types of data by excluding some types of data, like here. So here we have estimations of data types. It's not always the best match here. What I mean by this is if we calculate the total memory usage here, well, that's 7 megabytes. But let us detect the column type and specifically set it to either Boolean or categorical, because Pandas data frame supports categorical label. We'll use the category threshold. It's the proportion of threshold for categorizing column based on uniqueness. Like if the column has a lot of unique values, well, let us treat it as a categorical. And yeah, we can define the numeric type here also. Either like if we have only 2 unique values, let's treat it as Boolean or binary. And detect object type, we'll again use categories and just objects. So let's try to apply this function, yeah. And we have the reduction of total memory usage here. So like after types adjustments, it dropped down like 7, almost 8 times. Yeah. Pretty impressive, I would say. So what about the statistical measurements? So let's take a look. We can calculate by hand the mean, the median, and the mode, or we can calculate the same values with NumPy by providing the data here. Yeah, we can calculate mode. We can calculate other statistics, and they are similar, or I would even say same, because, well, we calculated it in a pretty good way. We can also use the pandas functions that are provided. Not a big deal, we can use it. As for the, and this is like the measures of central tendency. What if we want to calculate the data spread, standard deviation and variance? We can do so. We can use the formula, the existing formula, and calculate them by ourselves, or by using, let's say, NumPy or Pandas data frame calculation. And by default, NumPy's standard deviation and variance functions calculate the proportion standard deviation and variance, while Pandas corresponding methods calculate the sample standard deviation and variance. Those are different. The difference is in the denominator used in calculations, and it leads to slightly different results, as you can see here. So here, here. And here. And to make Pandas calculations match those of NumPy's default behavior, we can set the parameter to 0 when calculating the methods, and we'll get the same value. What about indicators of distribution shape, skewness, and kurtosis? We can do so. We can either calculate them by hand, like this, using formulas, or calculate using SciPy methods or Pandas methods, or like some, let's say, other methods with bias switched off. We can notice that the data will vary. And that's okay, as I mentioned in the lecture. So you need to keep in mind that you need to have this bias adjustment. And what about the categorical data? You can calculate frequency counts by using value count in Pandas, like this, or you can have some kind of function like this and calculate the value counts, mode, number of uniques, missing values, and create yourself a nice looking report. That's it for this part. Welcome back. Now let us focus on univariate analysis. It involves analyzing one variable at a time. Univariate analysis aims to understand the distribution, central tendency, and spread of the variable. And the key objectives here are identify patterns, like detect trends, anomalies, and outliers in the data, measure distribution, like understand whether the data is normal, skewed, or bimodal, aid in data cleaning. It helps spot missing values or inconsistencies that need corrections. To effectively explore a single variable, we have a range of visualization techniques to use. Histograms allow us to see frequency distributions clearly. Kernel density estimation smooths out the noise to give us a continuous view of data density. Empirical cumulative distribution function, or ECDF, plots of this function helps us understand cumulative distribution and percentiles. Box plots summarize key statistics and highlights outliers. And violin plots provide a dual view of statistical summary and data density. And each method serves a unique purpose, and when used together, they offer a complete picture of your data. Histogram is one of the most straightforward visualizations available. It groups data points into bins and displays the frequency of observation in each bin. This simple yet powerful tool allows you to quickly assess most, when used together, they offer a complete picture of your data. Histogram is one of the most straightforward visualizations available. It groups data points into bins and displays the frequency of observation in each bin. This simple yet powerful tool allows you to quickly assess whether your data is normally distributed, skewed, or even bimodal. For instance, if you see a long tail on one side of the histogram, it indicates skewness, a clue that you might need to apply a transformation before processing with further analysis. The histograms are simple to calculate, simple to plot, and use it wherever it's possible. Kernel density estimation, or KDE, is a non-parametric way to estimate the probability density function of your data. Unlike histograms, kernel density estimation doesn't rely on fixed bins. Instead, it produces a smooth curve that gives a better visualization of the data's underlying structure. This is especially useful when you are unsure about the form of the distribution and need a continuous approximation to guide further analysis. And ECDF, or empirical cumulative distribution function, plots the cumulative probability of each data point. This visualization shows you how data accumulates over its range, which is incredibly useful for understanding percentiles and the overall spread of the data. With an ECDF, you can easily identify what percentage of data points fall below a certain value, and this is important insights for many statistical analysis. Again, it's also easy to calculate and use to plot. A box plot is a powerful yet simple tool that displays 5-number summary of the feature or of your data. The minimum, first quartile, median, third quartile, and maximum. What makes box plot particularly useful is their ability to highlight outliers, those data points that deviate significantly from the rest. The outliers for the box plot are calculated like Q1, or like the 25th percentile, minus 1.5 multiplied by IQR, and this is the minimum, and everything lower than minimum is outlier. The same logic applies to maximum, and maximum is like 75th percentile, or Q3, and you have Q3 plus 1.5 multiplied by IQR, and this is your maximum, and everything above this maximum is an outlier. And interquartile range, or IQR, that's basically the difference between Q3 and Q1, or like 75th percentile and 25th percentile. So this quick snapshot is valuable when you're looking to assess the central tendency and spread of your variable at a glance. But box plots can be improved, and violin plots take the concept of a box plot and enhance it by incorporating a EDA curve. This combination not only shows the 5-number summary, but also provides a visual representation of the data density. And for data sets with complex distributions, a violin plot can reveal nuances that a simple box plot might miss, offering a more complete picture of the data's shape. And this is the example. So again, the data is specifically generated in order to have the same box plots for the raw data and for like synthetically raw data, but like box plots look similar, and they are similar. However, for the same data, the violin plot will show you like there is a difference. Let's have some coding. And welcome to univariate analysis demo. It focuses on analyzing individual variables independently to understand their distributions and characteristics. And we start by exploring sale price, one of the most critical variables in this dataset, since it represents the selling price of a house. And to understand how it is distributed, we need to compute quantiles, which divide the data into different percentiles. This helps us determine thresholds such as median, which is the middle value, and quartiles, which help identify lower and upper limits for pricing trends. And we can do so by using pandas function. Next, we're moving on, and to use histogram to visualize how frequently different price ranges. So we create this histogram using either matplotlib or seaborn. And histograms are essential because they provide a visual representation of the data distribution. We can do so easily. So the number of bins that we're dividing, the colors and titles and so on, the same here. As for the kernel density estimation, so to refine our understanding, we generate this plot. And it smooths out the distribution, giving us a continuous curve that represents density. We can do so by either calculating it like this and using matplotlib, or by using seaborn and printing it out. Both options are okay. We can make it nice looking like this with different colors and so on. As for the empirical cumulative distribution function, or ECDF, again, we can compute it, we can plot it. It shows the cumulative proportion of data points up to a given value. This is super useful. We can do so by using a pandas approach or to any other approach, but here is like the illustration how to do it in pandas. In pandas, firstly, we calculate it by sorting and applying a cumulative sum, and then just by plotting it. What about the box plots? They help us identify outliers and help us get the information about the data distribution. We can calculate them and plot them by using model boxplot in matplotlib, or the function boxplot from model matplotlib. We can also use the seaborn implementation like this, or we can calculate like the IQR and all the numbers by ourselves. That's also an option. Moving on to the violin plot, it combines the representation of the boxplot with kernel density estimation to show the distribution. We add markers for like mean, median, and mode, and we can use seaborn violin plot to plot it. Just to illustrate the whole thing and make the illustration more interesting, so we can plot the mode, the median, and the mean by combining the seaborn and the matplotlib like this needed. And that's it for this demo. Welcome back. And we continue with bivariate analysis, meaning like what if we have two variables for our analysis. Now we explore how two variables interact with each other. And this is a crucial step in understanding dependencies and correlations, which are the backbone of predictive modeling. We'll also try to find trends between two variables and like how one impacts another one. And without this analysis, there will be no regression, classification, and any other predictive modeling. To analyze relationships between two variables, we can use a range of visualization techniques. For quantitative data, scatter plots and correlation matrices are very effective. For categorical data, bar charts and cross tabulations are often the best choice. And when you have mixed data types, you may need to combine techniques to get the full picture. And each visualization method gives you a different angle on the data, enabling you to detect trends and dependencies that are crucial for building robust predictive models. A scatter plot is a simple dependencies that are crucial for building robust predictive models. A scatter plot is a simple yet powerful visualization that displays the relationship between two numerical variables. Each point represents an observation, and by examining the pattern of points, you can understand whether there is a positive correlation, where points slope upward, a negative correlation, where points slope downward, or no correlation at all, when points appear scattered randomly. Scatter plots also help identify clusters of data and outliers that might otherwise distort your analysis. A correlation matrix provides a bird's eye view of the correlation and relationships between multiple variables at once. So this table shows the correlation coefficients, and the coefficient ranges from -1 to 1, indicating the strength and direction of the relationship between variables. And it is useful when working with many variables to detect patterns in one view. So how to interpret? 1 indicates perfect positive correlation. -1 is perfect negative correlation. And 0, it's no correlation. However, keep in mind that correlation might not show you like the real dependency between variables, because some correlation coefficients are designed to only detect linear dependency. So dependency might not be linear. However, like the correlation heat map is incredibly helpful in quickly pinpointing which variables have significant relationships and deserve future exploration. And yeah, correlation does not imply causation, so keep in mind. And deserve future quickly pinpointing which variables have significant relationships and deserve future exploration. And yeah, correlation does not imply causation, so keep in mind. You need to double check everything. Cross-tabulation or contingency tables are great tools when you want to analyze the relationship between two categorical variables. These tables display the frequency counts for each combination of the categories, enabling you to see patterns of association or dependency. For example, you might use cross-tabulation or a contingency table to see how passenger class relates to survival rate on the Titanic. It's an excellent way to begin understanding the interplay between categorical variables before moving on to more complex analysis. So high counts in specific cells indicate a stronger association between categories. And here we have the distribution of overall quality across neighborhoods. We have neighborhood and like the count, like the overall quality. And we can see some patterns here also. Joint plot. A joint plot evaluates the concept of a scatter plot by adding marginal histograms or KDA plots along the axis. This combined view not only shows you the relationship between two variables, but also gives you an understanding of their individual distributions. This comprehensive visualization is perfect for understanding both the overall trends and the finer details of each variable's behavior. Again, you can see here the correlation, you can see the data shape here, and it contains more information than you'll just use scatterplot. There is another version of scatterplot is Hexbin, and when dealing with very large datasets, a traditional scatterplot can become too cluttered, too noisy, making it hard to show any pattern. Hexbin plots solve this problem by grouping data points into hexagonal bins. The color intensity of each bin represents the density behavior. Again, you can see here the correlation, you can see the data shape here, and it contains more information. Then you'll just use scatterplot. There is another version of scatterplot is Hexbin, and when dealing with very large datasets, a traditional scatterplot can become too cluttered, too noisy, making it hard to show any pattern. Hexbin plots solve this problem by grouping data points into hexagonal bins. The color intensity of each bin represents the density of data points in that area, revealing patterns that might be obscured by overplotting. This technique is particularly effective when you need to visualize density in a clear and organized way. What about bar plots? Bar plots are among the simplest yet most effective ways to compare a numerical variable across different categories, whether you're comparing average incomes across regions, or the number of occurrences of different classes in a dataset. Bar plots allow you to quickly and clearly see differences between groups. Their simplicity makes them ideal for presenting data to a wide range of audience. For example, it's ideal for categorical data such as gender versus salary or education versus income. A pair plot, it's a powerful visualization that creates a matrix of scatter plots showing every possible pairwise relationship among your numerical variables. And this comprehensive view allows you to detect correlations, clusters, and anomalies across multiple dimensions simultaneously.
Tell me that though. It's a fucking pair plot.
It's an excellent tool for the early stages of data analysis, where you need to quickly look at the data and decide which variables interact with one another. It's a great choice for exploratory analysis. However, it might take some time to plot. And in today's demo, I'll show you how to create scatter plots, correlation matrices, and other visualizations. And this is bivariate analysis demo. In bivariate analysis, we explore the relationship between two variables. Let us review the sale price and ground living area. So a scatter plot here helps us see how house size influences price. We can do so by using Seaborn, by having this scatter plot, but it's not as informative as we would like it to be, although we can see like the slope here, but let's try to build it with a regression line and like correlation coefficient. We can do so just by providing the relevant parameters here, and yeah, we can have the regression line. And what if we would like to have like the coefficient, the Pearson correlation coefficient, and the exact equation of the line? We can do so. We'll need to apply stat models to perform a linear regression just to calculate this line. We can calculate the Pearson coefficient. Pearson correlation coefficient can be calculated here. And yeah, we can add everything to this plot. What we can say is there is definitely a correlation between the sale price and the ground living area, and it's a positive correlation. So bigger houses have higher prices, and we can like make this conclusion just by looking at this graph. And let us move to the correlation matrices. We can calculate them using the standard pandas approach. So there are different correlation coefficients that can be used here, like it's Pearson, a Kendall, and a Spearman, and it returns the correlation matrix. This matrix helps us analyze multiple numerical variables at once. And we can plot this heat map. What we can say by looking here is that the closer coefficient to 1, the more the data is correlated, and we can just make this decision by looking at this correlation heat map without looking at some numbers, some coefficients. And using correlation, let's say, characteristics, we know that this matrix can be diagonal, since like the diagonal value here is always 1, and the data is symmetric, so we can just utilize a part of the whole heat map, the lower triangle, for example. What about the cross tabulation? Well, for example, we examine how overall house quality varies across different neighborhoods using a heat map. This helps us understand regional differences in home quality. We can do so. We'll need to calculate the crosstab of the overall quality in the neighborhood, and then just use the heat map. And here you have it. As for the joint plot, we can use Seaborn to just plot it. However, we can make it like even fancier by combining the scatter plot, the nice scatter plot, with the regression line coefficients and Pearson correlation coefficient and the R² of this line, and by providing really insightful information like mean, median, and standard deviation of the features. We can do so by calculating everything, by providing this information and adding statistics for access by using matplotlib and Seaborn. That's how we do it. Again, the hexplot being it's not a big deal to calculate it using like matplotlib. You can calculate it like this. You can use the color bar, and you can even make it more, let's say, fancier by using this joint plot and having not like the previous version, but combining with the hex bin. And as for the bar plots, well, that's a standard thing. Actually, we can use the Seaborn and just provide the values here, the features here, and here you are. And calculate them. However, we can make it like even fancier, and that might be more, let's say, informative and more nice looking, because here we can have like the standard deviation value, we can have the exact values here, and so on. This is the code. You can review it. There are some pandas calculations, Seaborn calculations, like we're adding exact values, but again, we can do so. And what is interesting here is that it's the number of garage cars. We can see that the average sale price by the number of garage cars is limited to 3, and then it falls, but for some reason we have no standard deviation for the 5 number of garage cars. Just a spoiler for you, it's because we only have one value of this in the dataset, so from one value we cannot calculate the standard deviation. And we can also calculate the box plots for this distribution, and this clearly shows that, well, we have only median, we do not have any data except one measurement, unlike the others. Because this might trick you, because you do not clearly see like how much data do you have, and here you can see it. Yes, and as I said, there's only one entity with these parameters. Again, we can group the data by using pandas group by, apply aggregation functions, we can sort them. So here what you can calculate and do just by using pandas. You can also calculate the thing using pivot table, just to simplify things. And again, pair plot. You can have the pair plots here by using Seaborn pair plot. You just need wait a little bit and it will be calculated. And that's it for this demo. Welcome back. Okay, but what if we have more than 2 variables? Well, that's where multivariate analysis comes into play. As we shift our focus to this type of analysis, multivariate analysis, we analyze 3 or more variables simultaneously. And this phase is crucial because real-world data rarely exists in isolation. Instead, multiple factors interact in complex ways. Multivariate analysis lets us expand our view. from isolated pairs to a broader picture. And by considering several features at once, you can uncover some complex patterns and interactions that are invisible in simpler analysis. The difference between seeing a flat, two-dimensional picture of your data and understanding its full multi-dimensional complexity. And this is the key for building accurate models and understanding how different variables influence each other. Let's have some examples. So, 3D scatter plot. It extends the conventional two-dimensional scatter plot by adding a third axis, allowing you to visualize the relationships among three variables simultaneously. This added dimension can reveal clusters and trends that aren't visible in 2D. Of course, 3D plots sometimes can be more challenging to interpret, but they are useful when you need to show like the 3D picture or some more complex interactions. Moreover, you can add the fourth dimension, like coloring, and there will be 4 variables shown here. And even more, if you add different size and shape, you can have like 5 or 6 variables shown in one picture. But sometimes it's a challenge to understand like what is going on, so you need to balance between the complexity and the simplicity of your visualization. Building on our earlier discussion of violin plots, we now look at like more complex representation. And these advanced plots not only summarize the distribution of one variable, but can also be segmented by adding categorical variables. And this layered visualization provides a richer context, enabling you to see how different groups compare in terms of their overall data distribution. And now let's have some demo. Welcome to the multivariate analysis. It extends bivariate analysis by examining interactions among multiple variables simultaneously. And we begin by enhancing our analysis. For instance, we can use group by function of the, let's say, cars, and apply the following aggregations. For sale price, we'll calculate mean, median, standard deviation, count, and for the area, we calculate mean and median. Using NumPy, we can do so. As for the 3D, we can apply something like this. So we can use our own dataset or use the existing one. We can zoom in, zoom out, and take a look at the data, like this. Rotate, we can do so. Keep in mind that we also have the overall quality here as a color, and we can do so by using Plotly. I really like Plotly for 3D plots, interactive plots. You can rotate and play around with this. You have the data available when you point the mouse at the point. As for the violin plots, so let's take a look how to plot them. You can do so by calculating value counts. We can calculate the violin plot here by providing all the necessary values. The neighborhood as a separator here, x, and the separator within would be the overall quality, and the sale price by neighborhood and overall quality. So here you have the colors, the overall colors, and the neighborhood, and you can see it, the sale price by neighborhood and overall quality. And that's it for this part of the demo. Okay, but what if neighborhood and overall quality. And that's it for this part of the demo. Okay, but what if you do not want to spend a lot of time building visualizations? You might think, well, since I know the type of the data and these approaches are standard, why not automate this? And that's a great question, because there is an automation in exploratory data analysis. And if you're either lazy or you want to save some time and be happy like this cat, you can use it, of course. Automation in EDA is a game changer, especially when dealing with massive datasets. And tools like Pandas profiling and SweetWiz and Detail can generate comprehensive reports in seconds. Manually, it would take you hours to compile manually. And why should you automate parts of your EDA? The answer is simple. Automation saves time, provides immediate results and insights, and ensures that your analysis is consistent and repeatable across different datasets. And when you have thousands or even millions of data points, automated tools help you quickly generate visual summaries and statistical reports. This efficiency allows you to switch from these tedious calculations to interpreting the results and create solutions rather than calculating code to creating code for these calculations. However, you should know what and how is calculated. Keep in mind that those tools are not super intelligent. They just automate things that you know, that you should know. And if you automate things that you cannot interpret or cannot describe, that's not the best option. So you should keep in mind that you must know what you are automating. And if we take a closer look at some popular EDA automation tools, for example, wire data profiling, often seen as Pandas profiling, and It provides detailed descriptive statistics, missing value matrices, and histograms, and a lot of nice things. SweetViz is particularly strong when comparing datasets, such as train and test splits, and often target analysis along with visual comparisons. And Detail, on the other hand, offers an interactive interface for in-depth data exploration, complete with filtering and sorting functionalities. And each tool has its unique strengths, and choosing the right one depends on your specific analysis needs. Okay, and why shouldn't you rely entirely on automated EDA? Automated EDA tools may miss the context and nuances of your data. They can overlook critical patterns or misinterpret anomalies if not reviewed by a human analyst. And relying only on automation may lead to a passive approach when you miss opportunities for deeper insights. It's important to remember that these automated tools provide a starting point. They are excellent for initial insights, but the nuances and the context that come from manual exploration are irreplaceable. Always combine automated reports with your own manual checks to ensure a thorough understanding of the data. In this demo, we'll see how these tools work. Welcome to this demo, and we will discuss the EDA automation. So we start with the same housing dataset, and nothing special. We just connect to the Google Cloud and load this dataset, load the descriptions. Here's everything similar again. Let's take a look at the pandas profiling or Y data profiling. We install it, install Jupyter extensions for this, and it goes like this. So you load the dataset. For the simplicity, I created a sample of this dataset just to speed up the calculations. And you create a profile report just for the dataset, and you save it either to file or to display. This is how it goes. So we have a sample, and you have some missing values, correlations, and so on. So basically, you have an overview, alerts based on your data with high correlation or imbalance or missing values. That is worth reviewing this reproduction. How it was calculated, and so on. Overview, like dataset statistic, variable types defined here. Variables, you can select columns, review them, or just review. So high uniqueness, high correlation here, subclasses. Again, all the information regarding your data can be found here. That speeds up your investigations. Again, let me just scroll it down because there are a lot of features here. And yep, some text data. Moving on, yeah, sale price distribution and interactions. So you can, if you like, you can have some interaction. You can build, you can plot some interactions between whatever features you like, and you'll have it. So again, really useful, super nice. Also here you have the heat map calculation. Then you can have it as a table, missing values, either as count or as a heat map here, and sample. SweetViz is another lib. Again, we install it, and it operates similarly to profiling lib that we had. So you can have the report on each variable here, similarly to what we've seen. Some missing information. Again, you can utilize it as you want. There's a lot of data here. As you can see, like the feature number and the information about this feature. And if you click here, you can have the statistics of this sale type, for instance, the sale condition. Again, this simplifies, and you don't need to calculate the whole thing manually. Just use it and review your data set. Super useful. Detail, it's a bit more complicated to use. Again, you set up this thing, you read the data set, and you show it, like you initialize it, and you show it. That's an interactive table here, and you have like the information about each variable. You can rename it, lock it, hide it, and whatever. You have actions, like show hide columns, convert, filtrate, apply some functions, merge, stack, summarize. You have a lot of visualizations at hand, highlighting, and all the settings. So I recommend reviewing this. If you like, maybe you'll like this better. And that's it. Thanks. Welcome back. What about visualization tools and resources? There are plenty of them. Visualizations at hand, highlighting, and all the settings. So I recommend reviewing this. If you like, maybe you'll like this better. And that's it. Thanks. Welcome back. What about visualization tools and resources? There are plenty of them. And visualizations transform raw numbers into stories, making your insights accessible to both technical and not technical audience. And visualizations are central to understanding and communicating your data insights. A well-crafted chart can make complex patterns immediately clear, guide decision-making, and reveal insights that raw numbers simply cannot. Whether you're using simple bar plots or interactive dashboards, the goal is to tell a story that is both compelling and accurate. And this is why mastering visualization techniques is an essential skill in data science. Remember, A well-designed visualization can often convey more than pages of statistical summaries. Advanced visualization libs like Seaborn, Plotly, and sometimes Altair, Bokeh, or ggplot provide powerful tools to create interactive and aesthetically pleasing visualizations. In addition, to their technical capabilities, it is important to consider accessibility. Keep in mind this. Using colorblind friendly patterns and palettes not only makes your visualizations more inclusive, but also enhances clarity for all viewers. The resources on this slide are excellent starting points. Please use any of this lib that fits you and try it. And in this demo, we'll explore several visualization tools and resources. And this is the demo for visualization tools. So we'll review just a couple of them. We'll have the ggplot. That is interesting to use. However, it's a bit outdated, I would say. But you can create nice looking diagrams with this. However, yeah, it is not interactive, at least here. You can use Plotly. I really like Plotly. It is interactive. You can zoom in, zoom out. You can have the information about each data point here. And that's super easy to use, similar like Matplotlib. Here, you just create a scatter plot. What else? You can have these nice looking box plots with all the information just by a single line and with all the interactions that you need or might need. Again, bar plot, scatter plot, interactive, 3D. You can rotate it, zoom in, zoom out. All the different types and shapes, for instance, like the pie chart. But please do not use pie charts. They're nice looking, but they're really hard to read. For example, this one is 30% and this one is 26%. However, they might seem pretty close to each other. So yeah, they're really hard to read. As for the bokeh, I really like it. That's useful, that's nice looking, that's interactive plot. You can use it, and you can create some sophisticated plots here with different sizes, with zooming in, zooming out if you like, moving around. And yeah, that's also, you can create the bar plot here. Yeah, it does not support 3D scatter plots. Altair, again, another lib that is very interesting to use, really easy to use, I would say, because here you can see like we created a scatter plot with different sizes, with different colors for the lot area and sale price. We could also add, I don't know, for instance, the shape here, but please don't use it, because even this is pretty hard to read. If you add shape here, you'll break somebody's eyes. Just joking. If you need, you can use it. Again, here you can have this, let's say, plot, this histogram by using the binning range. It's a bit more complicated to calculate and to plot histogram here than just using something from the Seaborn. However, like, you can save in different options, and Maybe you'll like it, because you can zoom in, zoom out. Here you can zoom in, zoom out. And that's it for today. Thank you. Welcome back. What about challenges? Challenges in exploratory data analysis. Let us discuss some strategies to overcome the common challenges there. So for missing data, you might use imputation techniques or decide to remove incomplete records if they represent a smaller portion of your dataset. And inconsistent data formats, such as dates or units, require standardization to avoid errors. Outliers need to be carefully identified and, if necessary, removed or transformed to prevent skewed results. And when working with high-dimensional data, techniques like principal component analysis can reduce complexity and prevent overfitting. And finally, addressing data imbalance by methods like resampling or using specialized algorithms ensures that your models do not become biased towards the majority class. And implementing these strategies is crucial to ensure that your insights and predictions are both accurate and robust. And we will dive deeper into each of these challenges during the data preparation lecture. Let's have some final remarks and recap. As we are moving to the end of our session, let's summarize what we've covered. Today, we explored the fundamental concepts and techniques of exploratory data analysis. We reviewed how to inspect data, perform univariate, bivariate, and multivariate analysis, and use a variety of visualization techniques to uncover patterns and relationships. And remember, EDA is an iterative process. Each insight you gain builds the foundation for better models and more effective decision-making. EDA helps you avoid common pitfalls and ensures that your data is well understood before you build any models. This iterative process will be a constant companion in your journey as a data scientist. The skill you develop here will not only enhance your technical abilities, but also empower you to think critically about the data. And to summarize, exploratory data analysis is not just an optional step. It's a necessity in any data science project. Finally, here are some resources that I highly recommend for exploration. The CRISP-DM framework, the Data Visualization Catalog, and various online guides on choosing the right visualization are excellent for expanding your knowledge. These tools and resources will serve you as your companions as you continue to refine your EDA skills and apply them to real-world data problems. It brings us to the end of today's lecture on exploratory data analysis, and thank you all for your attention. Remember, the ability to thoroughly explore and understand your data is what sets apart great data scientists. Every dataset holds a secret waiting to be uncovered, and with the skills you've developed, you are well equipped to explore, analyze, and innovate. I hope this session has provided you with not only technical tools, but also the critical reasoning needed to excel in your projects. I encourage you to continue practicing, ask bold questions, and never settle for the surface-level story that your data might initially tell. Your curiosity and critical thinking are your greatest assets on this journey. I wish you all the best, and I wish you advance through the course and beyond. May your analysis be deep, your insights transformative, and the future as bright as the discoveries you make. If you Welcome to today's lecture on data preparation, a crucial step in any data science project. I'm Dr. Andrei Holz, and we will explore why data preparation is the cornerstone of machine learning. Without it, even the best algorithms will fail. Imagine training a model to predict heart disease. With missing or incorrect patients' data, the outcomes could be dangerously wrong. Today, we will learn how to ensure data quality to build accurate and insightful models. During previous lecture on exploratory data analysis, we highlighted key challenges. It was dealing with missing data, managing inconsistent data, identifying outliers, handling high dimensionality, and addressing data imbalance. During this lecture, we'll cover missing data and outliers, and we'll leave high dimensionality and data imbalance for another lecture. So let's focus on those challenges. Today's agenda, we'll understand the role of data preparation in machine learning pipelines. Then we'll go to data cleaning and talk about missing values, duplicates, and outliers. Then we'll move to data transformation and encoding, following the data preparation challenges, and then we'll have a summary and wrap up. Let us move on. And to understand data preparation in context, let's take a look at the CRISP-DM framework. You probably remember this CRISP-DM diagram from the previous lecture. We covered the data understanding step during the exploratory data analysis, and now That's a data preparation step. So let's move on and see in details what it includes. Although data preparation is repetitive, but it is essential. It contains of selecting the data, cleaning the data, constructing data, integrating and merging the data into like data set, then formatting data, and in the end you have a data set. Ideally, after the data set preparation, you should have the data set description or the data set card describing each feature, describing how the feature was collected, created, and it's a kind of internal documentation that helps you understand what was going on and how you ended up creating this data set. So let us move further and talk a little bit about the data preparations. Data preparation can feel repetitive and boring, but it is essential. Think of it as building a house. No matter how well designed the walls or roof, without a strong foundation, the house won't stand. Data preparation is this foundation. It ensures your data is reliable and ready for analysis. It takes up significant amount of time, but quality data in means quality insights out. So as I mentioned, not only garbage in, garbage out. Let us hope that we have quality in and insights out. Importance of the data preparation is crucial. Consider healthcare data, where missing values are not addressed, and this could lead to serious biases in model predictions, or a financial data set with extreme outliers in transaction amounts. These could skew the model. Thoroughly cleaning the data, handling outliers, and filling in gaps ensures that our model are reliable. Today, I want you to see data preparation as a way of reducing uncertainty in the data and in the results. As for the data preparation steps, we can break down them into like this collection that you see on the screen. It's data collection, just gathering all necessary data from relevant sources. We won't cover this during the lecture. Data cleaning and data transformation and encoding will be covered during this lecture. As for the feature selection, feature generation, dimensionality reduction, that's a topic for a separate lecture. We will cover this. And the same goes for data splitting, cross-validation, data leakage prevention, and building data pipelines. We will cover them during the upcoming lectures after we take a look at some machine learning models in order to use the models in the pipelines. Let us move to data cleaning. Data cleaning ensures our dataset is complete, consistent, and accurate. Imagine a heavy dataset where age, income, and gender are the features. If some rows are missing income or have incorrect data types for gender, the model's learning process will be compromised. And data cleaning involves correcting those issues, filling in missing values, removing duplicates, and standardizing formats. So again, clean data leads to more accurate models and better decision making. The first step is missing values. Missing data is common and occurs for various reasons. Entry errors, technical failures, participants refusing to answer. Like there are numerous ways you could have missing data. Missing data can be categorized into the following three buckets. So it's missing completely at random, MCAR, missing at random, and missing not at random. Understanding why data is missing helps us choose the appropriate handling method. For instance, MCAR, completely at random, can be deleted without bias, but MAR and MNAR require more careful imputation or deletion. I can give you some examples. Missing completely at random. The probability of a value being missing is the same for all observations. For instance, imagine we're having a survey, and the survey is about, let's say, the income level. Survey responses are missing because some participants randomly choose not to answer. They just don't like to answer surveys in general. Nothing to do with the data or with the question. Missing at random or missing conditionally at random. The probability of missingness is related to some of the observed data, but not to the missing data itself. For instance, older individuals are less likely to report their income in a survey, and the missingness of the income value in this particular case depends on the observed characteristics, age, but not on the income value itself. And as for missing not at random, people with higher incomes are less likely to report their income, and the probability of missingness for this particular survey will be related to the value of income itself after a certain level of income, of course. That's the idea behind it. How we handle this, it's either deletion or imputation. And what about methods for handling missing values? As for the deletion, you can either remove the whole column. Imagine like you have only 10% of the data and everything else is missing data, you can drop it. The second option is you can drop rows from the data set that contain missing data. Again, not the best option because you are losing the data. A least-wise option is also a bit tricky. In this case, you remove missing data only if it is included in some calculations. If not, you're keeping it. Again, not the best option because your metrics, your calculations won't be consistent, so they will be biased. What about the imputation? Here, you should take into account the type of the data you're dealing with, whether it's time series data or general data. So for the time series data, it also depends whether there is seasonality trend or there is no seasonality trend. I won't stop here. Like in details, we'll discuss this time series imputation during the time series lecture. As for the general data, so it depends whether it's categorical or numerical, but in general, you can use mean, median, or mode. It's a straightforward approach. You can use some models, like you can use predictive modeling, just try to predict the value of this missing spot. Or you could use some information about the neighbors. Let's say you select the similar objects and just mark this missing spot as the most common around the neighbors. Again, we will cover some of them during the practical session. Yeah, and as I mentioned, there are several approaches and techniques like this meme. It's usually data is not missing, it's just relatively unknown. We will cover the methods for imputing during either the practical session or during the next lectures on the specific topics. Let us have some coding and we'll take a look the practical session or during the next lectures on the specific topics. Let us have some coding and we'll take a look at the missing values, how to deal with them, which techniques should we use, and what are the tools to do this. Hello and welcome to the demo of the missing values analytics. We'll start with the routine. Let us mount the Google Drive, load some libs, and load the dataset. We'll be using the housing dataset. For this dataset, we have description. It will be useful later on. And let us start with a simple missing values analytics. Let us count everything that is null. Here we can see per column countings, and some of the values are pretty high, I would say, especially like pool. QC means pool quality. Let us visualize the missing values. We can do so by applying the color palette that is like gray for our convenience. You can use whatever color palette you like, using Seaborn heat map. And here you go. And as you can see, LA, the pool, and some others are almost empty. It might indicate that those values, those missing values are actually not missing. They're just none. It means that what is meaningful is the existing of the value, not the like emptiness. Let us sort the values and see. Yeah, 99% of the pool quality is missing. I would say it means that 99% of the houses have no pool, meaning none of pool QC should be like category to category. And that brings us to the missing values type, like missing completely at random, MCAR, missing at random, MAR, and missing not at random. Let us calculate the example of different types of missing values, and we'll imitate them by using masks here, applying to the ground living area. We'll also use t-test to compare the means of the original and simulated datasets to check if the differences are statistically significant. We set the p-value at 5% level. So in order to check MCAR completely at random, I'm just masking completely at random the 5% of the dataset. We'll calculate the statistics, the changes, and so on. As you can see, like the change here is like 5% in count. However, it almost did not affect the mean, 0.3% of change. It affected the mean, the minimum value, but in general, and the t-test confirms that the change is not statistically significant if we take a look at the mean value. Let's move on to the MAR. This MAR means that the missingness is related to other observed variables, but not to the value itself. We will use the garage type detached as a reference to simulate this. If the garage type detached, it will be none. We'll just calculate everything. So this, again, just a reminder, this is our simulation. We calculate all the statistics. Let's just see what I have. Data with MAR simulated. For this one is 700. We can see that the change in count will be 26, almost 27%, leading to 5% error in mean. The change is statistically significant according to t-test. What about NAR? So it's not at random. Since the missingness is related to the value itself, let us just cap it, and if the ground line area is above some threshold, we'll just place nan here and calculate all the statistics once again. We can see that we have almost 10% change in mean and 34% change in standard deviation. Let us take a look what was the change for the standard deviation in MAR. It was 5% in mean and less than 1% in standard deviation. And here we have 34%. That's a huge change. And of course, this change is statistically significant and it is detected by the t-test. Going back to the pool quality, let's take a look. I calculated here the mean sale price for different pool qualities, including nan. And what we can see here is when there is a pool and it is of a good quality, the price is higher than for the nan, meaning that if there is no pool, the price might be higher. And I think that's meaningful. The same actually goes for other features that we mentioned, and you can take a look at the percentage here. Let us just introduce another category and use none as a category here, because obviously that's a category. Let us check the listwise and pairwise deletion. So listwise, like the simplest one, just let us drop the rows where there is none. That brings us to the loss of 24% of the data if we remove rows where there is a none. And as for the pairwise, let us imitate the nones, the level of 5% randomly. Let's take a look. So what if we just get rid of some values? I mean, we use pairwise deletion, meaning that we remove only the data if we need to calculate something that cannot use nones. Let's take a look. For this, we have like pairwise removal of 5%. Since we imitated this 5%. As for the correlation matrix, we can see a change here, but it's not dramatical actually, so it's like the third digit since we're removing 5% of the data. Imagine now we successfully identified the outliers. Now we need to impute them. Let's start with the simple imputing methods. We'll use the copies of the dataset. We'll start with the mean imputation for the numerical column. You can use a simple imputer from the sklearn impute. Of course, you can impute the data by yourself. However, I highly recommend just use sklearn's impute. Take a look at the documentation. So at the parameters here, you can set up the strategy type, fill value, copy, indicators, and so on. As for the strategies like mean, median, most frequent, constant, filling value for the constant, and all the attributes, skip empty features, add indicator, just use it. Of course, if you want, you can create your own or use some other tool, but sklearn is a great lib, so please use it. We'll use it heavily later on. Let's move to the most frequent, apply to garage type, and constant. Now, since we applied all those simple imputing methods, let us calculate statistics. As we can see here, the mean did not change since we imputed the mean, but the mean changed when we used constant. And again, just a note, for some distributions, it's better to use median, not mean. It highly depends depends on the type of the distribution. Which one to use? Well, it's a tricky question. It highly depends not only on the data set and the distribution of the data, but also on the machine learning model that you are using. I think we'll cover those nuances during the feature engineering part. Today, we're just taking a look at the imputation approaches. Let us calculate the statistical significance. As expected, mean imputation did not significantly change the distribution. However, constant imputation did change the distribution. Let's take a look at the categorical. Well, nothing changed, but that's a toy example. Sometimes it might change if you have a huge amount of missing values. Let's take a look at the advanced imputation techniques. Those include machine learning modeling like KNN imputer, iterative imputer, some linear regressions, and so on. We won't stop on the exact implementation and details of the implementation. We'll just use those tools to impute missing values data. Let's take a look. The missing values for lot front page is 400, almost 500, and garish type is 157. Let's start with the linear regression imputation for numerical values. What it does, we just train regression on the existing data and fill the missing data. That's a toy example, so in order to make it robust and clear, you'll need to have more sophisticated pipeline, but this is a toy example. I'm just showing you how to use it. It is applied, so yeah, as I mentioned, train and test, just sanity checks here, like have a predicted value, and we impute the null values with the predicted values. What about nearest neighbors?
Fill in the missing data with like predicted data. Is that even... That could maybe work. That's like... There could be issues with that, like a lot. It's like, imagine if I had like a survey about what people think, and then I would just take other people's survey and, I don't know, redo the questions again. I guess as long as you say that's what you're using in your research, then by all means. But like, can you prove then that your research is significant? You know, that's the issue about it. Like, you need to have like a lot of data to be able to like fixing some of the missing data with some predicting data is an interesting idea, but it's like, you know, like how can we know that those predictions are going to be based off of the data that you already have, right? So it's just like, I don't even know, man. Maybe like I don't know if that's a good idea. That sounds too good to be true almost, you know? Like, it's an interesting idea to use predictions to clean up your data, but I feel like that's just stupid. You would rather want to delete your data and just like not try to predict fucking... Yeah, that's crazy. Yeah, that's just crazy.
Imputation. K-nearest neighbors is a machine learning method to find the neighboring objects of your object, meaning that in some metric, in some place.
Yeah. That's just bad. That's just like, it's exactly what that IQ test was doing, where they were like measuring the statistical average data of like different countries, right? The statistical average IQ of countries, right? And what they did, like, that paper is like infamously for being like criticized, because what the researchers did there, they took the average of IQ when they didn't have enough IQ for IQ scores, but they didn't have enough data for the IQ score to output an average of the IQ score for the country. They took neighboring countries' IQ scores and just combined them together to put into that country. That is just... Like, you have to be really, really careful on what the fuck you're doing when you're doing stuff like that. Because, like, that's like... How can you say that your data could be significant if you're doing stuff like that? I think that's just like... It's fine as an idea, but it's just like, in practice, you have to be really careful doing this kind of shit. Like, what... Missing values imputation is not that good of an idea in my opinion, but yeah.
They're close to each other by some distance. You can take a look at the detailed explanation of the nearest neighbor imputation, but the idea is, let us find the objects that are close to this one and use their values to fill missing values for our object. Yeah, and we apply this and we'll later take a look. So, and as for iterative imputer, it is similar to the linear regression. It uses a more sophisticated regressor, but again, it fits on the existing data and predicts the missing data. That's the idea. Again, it is an existing iterative imputer from sklearn, so as the KNN imputer. You don't need to write your own. What about the categorical values? Well, there are sophisticated approaches to use, but let us be simple and we'll just use an existing simple imputer with the most frequent. Let's take a look at the statistics. As we can see, like, the mean changed a little bit depending on the different type of imputation, but that's not a great change. Yeah, same for the standard deviation. Let us calculate the statistical significance of change in means. As we can see, the statistical tests show that the difference is not huge. It's almost the same distribution. What about the categorical imputations? We'll calculate the chi-square significance here based on the imputations, the most frequent and the a simple imputer, like they're the same actually. Well, the change was not dramatical. Let us visualize the imputation effects. We'll plot the data and take a look how it changed. We have here the density plot for plot frontage. Here you can see the original and the imputed data, and each of the approaches changed a little bit here. Let's change the data a little bit. We can see here the result of the imputation. For each method, the density is a little bit different. However, it still remains the same distribution. That's for the categorical data. We can see attached as the most frequent had more values. Okay. This is just an interpretation, p-values, and so on. That is it for the missing values. Welcome back, and let us continue. Duplicate data entries can distort our model's learning. For instance, if customer data is repeated multiple times, the model might overestimate the importance of certain customer behavior. Removing duplicates ensures that every data point is unique, reducing the bias in learning process. That's pretty straightforward approach. You just look through the data or just analyze the data and try to find exact matches of the data and just get rid of it. We don't need like the exact matches of the data. However, we need to be sure that the exact matches are really duplicates and not some meaningful data. That might also happen. So just keep in mind the situation and the domain. So maybe in your specific case, that's not a duplicate, it's just another object. Okay, and let's talk a little bit about outliers. So outliers are extreme data points that derive from the rest. For example, if employees' salaries fall between 40,000 and 70,000, but there are a few above 1 million, those are outliers. Outliers can result from errors, or they can also represent unique, valuable cases. Depending on the context, we might choose to remove them, keep them, or transform them to reduce their impact. And what about traditional outlier detection methods? Well, there are plenty of them, and some of them you can see in this slide. We can use like scatterplot and visually inspect the data, or box plot for visual inspection. And also we can have simple statistics like IQR, interquartile range, or Z-score, or Cook's distance. Z-score measures how far a point is from the mean. Typically, outliers are beyond 3 standard deviation. That comes from the normal distribution. IQR, points outside of 1.5 times the interquartile range are flagged as outliers. And Cook's distance, it identifies influential points in regression models that may disproportionately affect the model. It is calculated by the formula, and we'll take a look at this distance on the practical session. So those are illustrations. You can clearly see here the different approaches, the IQR distance calculation, the probability of some point being in a specific place of in the distribution on the box plot here. So, and what about the advanced outliers detection techniques? Well, you can use k-means, like basically you can use machine learning and modeling to identify outliers. So k-means, dbScan, and all those approaches are ML-based models. We'll definitely take a look at them, but I want you to know that there are different ways to detect an outlier, and not only by classical statistics, but also with the machine learning. For instance, k-means, just outliers are points far from the cluster centroids. dbScan, outliers are in low density regions where no clusters can form, and isolation forest is a way to use the decision tree. We'll you to know that there are different ways to detect an outlier, and not only by classical statistics, but also with the machine learning. For instance, k-means, just outliers are points far from the cluster centroids. dbScan, outliers are in low density regions where no clusters can form, and isolation forest is a way to use the decision tree. We'll discuss like decision trees and lectures a bit later, not during this one, but those are tree based. And yeah, so there are like advanced outliers techniques, and we can take a look at some of them. Yeah, so using dbScan, as I mentioned, here like circled are outliers. There is a low density around them, and the points here, like in the bottom, the red ones, are like with the most density. Decision tree can be used to find outliers. Outliers are few and far from the rest of the observations, and we can use this logic to try to isolate them. We can use deep learning based techniques. I won't stop here for long because this requires a fair amount of understanding of the deep learning, but we'll get back to them during the deep learning sessions. Time series and multivariate outlier detection of understanding the deep learning, but we'll get back to them during the deep learning sessions. Time series and multivariate outlier detection is also an option. We'll discuss those options during the courses, the lectures of time series. So for you just to know that there are options to do so. Let us move on. Imagine we have successfully identified outliers. So what should we do next? There are several options for this. We can remove, that's the easiest way. We can impute them with more appropriate values, or we can transform them. We can apply some transformations to the feature and minimize the effect of the outliers. As for the removal versus skipping, so it is safe to remove the outliers if their nature is like errors or they're just irrelevant, but it is important to keep if the outliers are informative, for instance, such as fraud detection or like salary outliers for some cases. This is a thing to keep in mind when you deal with outliers. So just do not only remove or keep or impute them, you should understand what is behind those outliers. For instance, you can impute the outlier with mode or mean or median and mark and create a separate feature, marking this object as an outlier. That's also a fair option. In this case, you will keep the information that there was an outlier, but also prevent the model from using this outlier potentially breaking. One of the ways also is to use like another metric metric, different types of metric, because for instance, if you use some metric regression, maybe the outlier will significantly impact your calculations, but if you have capping or truncated loss, your model won't be affected. Again, a clever way to deal with the outlier. Another way is to use regularization of models, but we'll discuss this during the lecture on machine learning models. And now let us have some code. Hello, and this is the coding session for managing outliers. As usual, we start with mounting the Google Drive with the dataset. We'll use the housing dataset. We'll import the libs. So we are heavily using sklearn's libs, and I highly recommend you to take a look at them. Of course, you can create those methods on your own just by the definitions and the theory behind them, but using sklearn's will just save you time. However, if you want to get into it, if you want to understand how everything works on a low level, I highly recommend try to implement the methods by yourself. Yeah, so let's move on, and we'll use 2 columns for managing outliers here. And we begin with the scatter plot just to take a look at the data. Visually, we can see here some outliers, and let us build the box plot. Once again, yeah, box plot. And you can see the whiskers here. Yeah, those are called the whiskers, like the cat's whiskers. And outliers are marked here. Since that's a ground living area, it is above 0 in any way, so we only have the right-hand outliers here. But it is possible to have both sides of outliers, depending again on your data. And since we have the box plot here, let us use the interquartile range IQR method to identify outliers. Basically, we can see them here, but let's just apply some mathematics. To do so, we need to have the 25th and 75th quantiles, just calculate IQR, and like have a lower bound and upper bound that are corresponding to those lines here. Yeah, so just like this, we will have the methods, and we'll also provide the scatter plot with the labels just to take a look at the data. Yeah, so as seen here, we have 75 outliers, all above some value here. We can either build it or just take a look here that is the same as here. Let's take a look at the, well, we're not interested in lower bound. Basically, our data is like about 0. But what about the upper bound? Yeah, so this is this line. Let us calculate the z-score. The z-score is kind of similar. It is based on the normal distribution, and based on it, yeah, we identify here like significantly less outliers than for the IQR. It's 25 actually, so you can easily calculate them. Just use z-score from stats module. Again, you can calculate this on your own. I'm using it just for the simplicity to speed up the whole process. What about the Cook's distance? If you remember the lecture, I was describing the Cook's distance there, and let us use it because we use again predefined Cook's distance. You can calculate it on your own, but I'll use it as is. Yep, and based on the Cook's distance, we can see here that there are a number of items that highly influence the data, the model, the regression model. 172 outliers here. Some of them are located in normal regions for some reason, but yeah, the majority seems to be fair labeled. Let's move to dbScan. So dbScan is a clustering method. It's a density-based method. We will discuss it during the lecture about clustering. What you need to know now is it operates based on density, meaning that it is important how many neighbors are there around and their location and their grouping. For dbScan, you do not need to provide the number of clusters. It can automatically detect clusters, like group the objects into clusters. With this in mind, let us try to cluster the data, and everything that is not in a cluster, we will consider as an outlier. Let's take a look. dbScan managed to identify the outliers here, 207. Let us maybe try to take a look at the data set. Let us plot dbScan clusters just to take a look at the whole data, not only on like the outliers detected, but the whole data. As you can see, there are 33 clusters defined. Some of them are like meaningful, some of them are really small, but -1 is our outlier. And you see how dbScan divided kind of layers. But let's move on to the isolation forest. So isolation forest is an algorithm that applies trees to separate the outliers. We can do so since trees are normally built with the entropy as a target, and if you remove the outlier, you reduce the entropy, since outliers are highly impactful. This is the picture of outliers. Again, we can see that the main data remains, just the regions are affected. And local outlier factor is another approach. Personally, I prefer the isolation forest, but maybe we can play around with the parameters here. Well, this is just an illustration. What about one class SVM? One class SVM is another approach to find the outliers. Surprisingly, there is a line detected as an outlier that I believe that should be investigated. And let's visualize all together. So here you can see all the outliers from all the methods at once. I use different colors and different shapes. I don't know whether it is useful or not. Some of the algorithms mark the data similarly, some of them not. One of the ways is just combine several algorithms and use ensembled decision. Yeah, we can also take a look at the data distinguished. Look here. And again, These are just some notes. And I highly recommend taking a look at the outlier detection document. And I highly recommend taking a look at the scikit-learn's outlier detection guideline. Please, that's super useful. That's it. Thank you. Welcome back. We're heading to the transformation and encoding. Transformation and encoding are used to ensure the dataset is in a suitable format. Scaling features like age and income ensures that the models aren't biased towards features with larger scale. Similarly, encoding turns categorical values into numerical ones so the model can understand them. Not every model can utilize the categorical data. We'll discuss this during the lectures on machine learning models. And this step is important, and it takes into account not only the data itself, but also the models that will be utilizing the data you are preparing. What about like scaling and normalization? Well, as for scaling, you can have like min-max scaling or normalization, classical normalization, and the data will be between 0 and 1. You can have standardization. Basically, you're trying to have a mean of 0 and standard deviation of 1. And there are also other approaches like robust scaling. They use different logic behind them, and we'll take a look at the robust scaler that is used in sklearn during the practical session or the coding session. As for the transformations, as I mentioned, if we apply used in sklearn during the practical session or the coding session. As for the transformations, as I mentioned, if we apply log transformation, our data will change. The data will change its shape. The outliers will be not so highlighted. This type of transformation reduces skewness, especially for right skewed data, and you can use it for large positive right skewed values. For instance, like transforming sales data to stabilize variance. Yeah, that's also like, or transforming income data. That's also a good use case. And again, always visualize the effects of your data transformation. That really helps, and that might provide you some insights about your data. Another transformation visualize the effects of your data transformation. That really helps, and that might provide you some insights about your data. Another transformation is box-cox transformation, which makes the data more normally distributed, and it's just another type of the transformation that uses power transform under the hood. There is also like a square root transformation. That's simple. You just apply square root to your existing data, and that's it. Another technique is data binning, converting continuous numerical data into discrete bins or intervals. Just imagine the histogram. Creating a histogram requires data binning. There are several approaches to bin the data. Like bins can be equal width or like equal frequency or like one tile based. As for the pros, it simplifies the data and reduces the complexity. Sometimes it can even bring interpretability. However, since it simplifies the data, it leads to information loss, some artificial cutoff points, so you need to clearly understand why and when to use each binning type. This is why I highly recommend that you use domain knowledge to define the bins. For instance, like binning ages into categories of youth, so young adult, and senior. Those are graphs that can help you visualize different binning techniques applied to the existing data set. Why data encoding? We'll now talk about the data encoding. So why it is crucial for machine learning. Data encoding helps us convert categorical data to numerical form, unlike binning. So in binning, we converted numerical to categorical. Now we would like to convert categorical to numerical. Those types of encoding allows ML algorithms to use features that are non-numeric, for instance, colors, city names, or genders. And we would like to convert this to numerical. There are various techniques: one-hot encoding, label encoding, ordinal encoding, target. And we would like to convert this to numerical. There are various techniques: one-hot encoding, label encoding, ordinal encoding, target encoding. Frequency encoding and binary encoding. What about like one-hot encoding? It's pretty simple. It creates binary columns for each unique category. Imagine we have color, we have a feature of color, and the values are red, blue, green, and those just separate columns for each color. Yeah. So for instance, you could have like red 0 or 1, blue 0 or 1, and green 0 or 1. Well, actually, if we have only 3 colors in the dataset, we do not need a third one. Yeah, we can have red and blue, and if there are zeros in red and blue, then the green will automatically be considered as 1, but we don't need it since it brings us the same information as zeros in red and blue. But this is only true if we do not have the missing data or outliers or something like this. Pros of this method: it is simple, it is easy to interpret, but it can lead to high dimensionality. Imagine you're applying one-hot encoding to something like car brand. You'll have a huge amount of features. As for the label encoding, it assigns encoding to something like car brand, you'll have a huge amount of features. As for the label encoding, it assigns each category a unique numerical value. Like imagine you have core class, and this can be converted into the numerical, or you have like animal types, cat, dog, bird, and so on. Well, it becomes 0, 1, and 2. It is simple, it is super memory efficient. Please keep in mind that it implies an ordinal relationship which can mislead models. For instance, if cat is 0, dog is 1, and bird is 2, it doesn't mean that cat is better than dog or cat is, or dog is 1 plus cat, and bird is like 2 dogs or whatever. Keep this in mind. And as I mentioned, ordinal encoding, this can bring us to the like label encoding, but with the categories within the order, like satisfaction, low, medium, high, 0, 1, 2, because low is less than medium and high is more than medium. There is a more sophisticated approach like target encoding. It replaces the categories with the mean or like median or like some functions based on the target. The great use case is like hard cardinality features like zip codes or car brands. Imagine we're encoding the car brand with a medium price. We can do so, and that's super reliable. However, we should be cautious, and because this can lead to overfitting if not handled properly. Please keep in mind that your data might become spoiled because of this technique. We'll discuss this technique during the modeling lectures and practical sessions. I wanted just to highlight that it exists. And we can also like encode with frequencies. We can replace categories with the frequency counts, and it's okay for categorical values with many levels, and it has low dimensionality. As imagine we're having a car brand that we would like to encode, and we could encode the car brand as how frequent this car brand appears in the data, and that's it, we just count it. Binary encoding here combines the label encoding and one-hot encoding to reduce dimensionality. It assigns each category a number and then converts this number to binary and splits it across different columns. Imagine like you have a binary encoding of something. The category 5 is a binary 1, 0, 1, and you have those columns, so 3 columns, and 1, 0, 1 is a 5. There are many other techniques, so I won't stop here, but some of them, like weight of evidence, hashing, we'll discuss during the next lectures. Just to highlight, well, the hashing is pretty sophisticated approach, but this one helps you reduce the dimensionality. That's pretty interesting and pretty useful technique. Here is the summary of basic encoding technique. You can later review it just to use as a guidance. And this is the summary of advanced encoding techniques. So just take a look at it. Later review it just to use as a guidance. And this is the summary of advanced encoding techniques. So just take a look at it, use it as a reference. I think you might be bored with this presentation now, and we have another coding session to cover transformation and encoding. Welcome everyone. Today we'll discuss crucial preprocessing techniques for data used in machine learning. Our focus will be on category encoding, scaling, transformation, and binning techniques. Each technique plays a crucial role in preparing data for models, ensuring higher accuracy and robustness. Let's dive in. We start as usual with mounting the Google Drive and loading the dataset, and we start with category encoding techniques. I'll start with the toy dataset just to show you different techniques on a small portion of data, just for you to understand how the things are calculated. And category encoding is used to convert categorical variables into numeric formats that machine learning models can understand. I'm using like the category encoder sleep, and I highly recommend it. It's super useful. Please pay attention and play around with it. So this is our dataset, nothing special. Let's move on. We start with one-hot encoding. One-hot encoding creates binary columns for each category. And since we're using a toy dataset, categories like A, B, and C are represented as binary columns. Let's take a look at it. Yep, that's it. We can even plot it and show it as a heat map. And here you go. We're moving to the label encoding. A label encoding assigns a numeric value to each category. For example, categories A, B, and C become 0, 1, and 2 respectively. This technique is more memory efficient, but may introduce an implicit ordinal relationship that isn't always correct. And here, like the ordinal encoding, it is similar to the previous one, but in ordinal encoding, we can define the sequence, the order of the categories. And sometimes it is useful, but yeah, please pay attention to it. Binary encoding. So binary encoding, it's a balance between one-hot and label encoding. It uses fewer columns than one-hot, but preserves more information. It is suitable for high cardinality features, like features with many categories. We're moving to the more sophisticated ones. It's a frequency encoding. What frequency encoding does replace each category with the frequency in the dataset. And categories that appear more frequently are given higher numerical values, which can be useful for certain models that benefit from frequency information. Just to double check. Yes, those are the frequencies or the counts. And let's move to the target encoding. It involves replacing categories with the mean of the target variable for that category. Here we're using the target encoder from category encoder sleep, but we can create our own custom cross-validated target encoder, and you can also create your own. The numbers here differ a little bit. However, it is due to the fact that in the category encoders, the encoding is more sophisticated than the one we used here. And I highly recommend taking a look at the category encoders. We're moving to the transformation. Data transformation can help stabilize variance, normalize distributions, or make the data more interpretable by models. And we start with log transformation. It is used to handle skewed distribution. Here we're using the LOT front page column. This technique helps compress larger values, making the distribution more normal, more bell-shaped and centered, I would say. We have another distribution distribution is Box-Cox transformation. This is a power transform. It works on positive values only. This distribution can also help with skewness, and it does so. Transforms the data in a different way than the log distribution. Here we also have the square root transformation. It helps with moderate skewness, and this transformation is especially helpful for count data where values range from low to high. And going back to encoding, I'll just show the encoding on the real data set, not on the toy example. Here you can see on the original data a lot of new columns were created just to transform this one into like one hot representation. Let's take a look at the label encoder, and we're moving to the binning techniques. And binning is a technique for discretizing continuous variables. If you remember the histogram, that's what it does. So we're converting the value into some set of buckets. Here we're using the same data set. I'll just refresh it. The numeric column for this will be the sale price. And just let us plot it compared to the index. By the way, you could notice here a very interesting shape. I think it's worth investigating, like this pattern. Let's leave it for the next sessions and focus here on binning techniques. And we start with the equal width binning. The range of values is divided into equal sized bins. In our example, sale price was binned into the equal bins, so 5 bins. That's similar to the distribution maybe. Let's move to the equal frequency binning. Equal frequency binning has approximately the same number of data points. It helps ensure that each bin has the same representation, which can be useful when the data is highly skewed. Because here the data is definitely skewed for the sale price, but let's take a look here. Here we binned the data. And we can also have the custom binning. It's based on domain knowledge. We can define custom binning, and here we created the binning sale price into medium, low, very high, and high, and the frequency of this binning. Yep, so again, histogram is also a binning technique. Let us plot the histogram. Let's take a look at it. Yep, it is also binning technique. Let us have the 5 bins. And 5 bins here are similar to the binning technique that was used here, equal width binning. So that's it. And as a conclusion, so choose the right technique. Choose scaling, encoding, or transformation based on data distribution, the model you are using, and the feature type. Try to avoid data leakage. Always use cross-validation when encoding based on the target variable to prevent overfitting. And visualization matters. Always visualize your transformations to ensure you understand the impact on your data. And that's it. Thank you. Hello, and let us continue. Common data pre-processing challenges. In real-world data preparation, there are challenges. Some of them come with ethical considerations. It's bias handling, fairness, and transparency. Like, imagine missing data. Missing data can lead to biased models, and biased models might not be ethical, so they will treat some groups unequally, or they will just have poor performance. This is the thing you need to consider. And the same goes with outliers, so they can damage the model performance. We didn't cover like the mixed data types during this lecture, but again, keep in mind that handling numerical and categorical data requires thoughtful pre-processing and encoding. You should know which feature is of which data type and why, because sometimes you can mix them up. And of course, the scalability, processing large data sets that cannot fit in memory and that requires efficient pre-processing strategies, including memory management, distributed processing, batch processing, or sampling, and even sophisticated methods to calculate statistics, because if your data set is not fitting into the memory, it might be tricky to calculate standard deviation, mean, and other characteristics. Let us wrap up. Today, we cover key techniques in data preparation: cleaning, transformation, encoding, and handling outliers. And each step contributes to the overall success of a machine learning project. And high quality data means high quality models, and the time spent preparing your data is always worth it. If you can invest either in data or in model, I would recommend investing in data. And I recommend you to experiment with various techniques. And remember that every data set is unique and it requires its own approach. And of course, domain knowledge and understanding of the domain. And some final thoughts. So data preparation is the backbone of machine learning. Even advanced algorithms cannot fix spoiled data. And making quality preparation crucial. Take your time with the data, understand it, identify missing values, distributions, and outliers. It is worth the effort. Experiment and iterate, test different cleaning, transformation, and encoding techniques. Please document everything. Keeping a clear record ensures reproducibility and supports collaboration. As I mentioned during the start of the lecture, in the end, you should have the document or the dataset card describing how you ended up having this dataset, which steps were applied, which methods did you use, and what was your idea behind applying each of the methods. The real-world datasets are messy, so effective pre-processing helps turn messy data into meaningful insights. Be thorough, experiment, and always remember, good data preparation unlocks the true potential of machine learning. Thank you for attention, and have a nice day.
Holy moly, I cannot believe it. Feel sleepy. Listening to late lectures take too much energy out of me, man. Once, let me sleep. Ah, I'm back, boys.
The plan doesn't change. We aim for the monolith. We keep heading north. With SKA's help, we can make it. But we lost the Lumina converter, so...
It's okay, we can think about that later.
All the backups were destroyed by that man, but Expedition 32 will bring more. Their chances will be better. We need to prepare them. I should update our journals. but-
Hey. It's okay. Tomorrow will still come.
Peak story.
Okay. You miss Gustav already? Me too.
Aye.
This seemed important. If you want to reach the monolith, the best path is through the quarry up north.
Who are you?
And where did you get that
Wee.
expedition uniform?
Strange way to say thank you. I'm sorry I couldn't save your friend. I'm wearing an expedition uniform because I, too, am an expeditioner.
What? What do you mean you're an...
I've never seen you before.
First expedition. Expedition Zero.
Expedition Zero. But how are you alive and not...
7 years ago.
I don't know exactly, but some of us stopped aging and were not affected by the Gamage.
Some of you. Like the man on the cliff.
Anwar, our commander.
Why? Why did he massacre our team?
How could he turn on his own people?
He believes his immortality is a gift from the Paintress. Killing her would kill him too, and he enjoys living forever.
And you don't.
Burying everyone you know while you live on can weigh you down a bit. I couldn't help your friend, but perhaps I can help you.
You want to join us?
If you don't mind the company. Yes.
Bro, she turned on Gustav so fast.
So, if I want to kill Renoir, I have to kill the
She was so
Paintress
flirty with
first.
Gustav, now she's flirting with this guy. Did you see that? Did you see that little smile she gave him?
What's your name?
Versa.
That's right. Gustav got turned on. It's over. Colonel Sanders is a villain. Wait, what? Oh my god. Verso level 26. Wait. He's the same level as Gustav? What? Wait, these are the same abilities as Gustav. What the hell?
They replaced him. They replaced him.
Wait, why does... He has all the same stuff as Gustav, chat. What the frick? He kept all his Lumina as well. Check weapon. Wait. Wait, he shares weapons with who? Wait, these are all his own weapons. Wait, no! These are all the same weapons Gustav had, but now they have abilities. What?
Oh my god, the design is also pretty.
Wait. Are you telling me I chose to solo the worst character and I hated his attitude because he was a simp and he was like kind of an emotional wreck and he never made logical decisions? So, they rewarded me by killing him and giving me a Giga Chad who actually doesn't make emotional decisions, who's cool and logical. Holy, what? Wait, did I hit the lottery? Did I hit the lottery, baby? Not only did I get to keep my character with similar abilities, but he got upgraded and he doesn't have an attitude problem. Yo, drinks to that, chat.
Oh my god, that's funny as fuck.
That's what I like to see. It's not the same. Close enough. Close enough. 600 IQ play. Wardrobe. That's what I like to see. Better. We're going to look at his abilities. All right, chat. We're looking at his abilities. Where's Verso at? What do we have here? Skill tree. So he has the same passive. Wait. He has the same passive thing where he generates charges, right? Wait, does he? No, he gives perfection. Not quite. You're right, you're right. He doesn't have the same passive. Let's see. So, from fire, deal medium single target damage, 3 hits, uses weapons elements. Yeah, whatever. And heal self if burn, whatever. Oh, this is different. He has A, B, and C. What the hell is B and C? Increases, wait, generate 1 additional, wait, critical hits generate 1 additional perfection. So he generates perfection. D gives more perfection. What the hell is A, B, C, and D? What is B, C, and D? What the hell is this? Let me see his big abilities. A can apply stun. S, increased damage. Okay, wait. After 1 turn, deals extreme single target physical damage, 13 hits. Interrupt if any. Wait, after. Oh, God. Wait. So I gotta use this, take no damage, and then I'm good? Interesting. 13 hits, extreme. That's S, though. Deals very high single target damage, 5 hits, uses... Okay, this is basically what we used before. It costs 7, just like before. Defiant Strike, deals high target damage, applies Mark for 2 hits. Costs 3% of current health. Okay. Deals medium target damage, 3 hits. Is increased for each health Verso is missing. Interesting. Removes all status effects. Okay. Applies them to Verso. Gains 1 rank. Oh, he has to gain rank. Extreme light damage to all enemies. 5 hits can break. Costs 5 AP if... Okay, that's interesting. Leadership. Reduces current rank. Gives 2 to 4 AP to other allies. That's support. Screw support. Powerful. Screw that. Low single gives more perfection on D rank. Deals single target medium light damage 2 hits. This is confusing. Deal medium light damage 1 hit. Increases for each free aim shot this turn up to 10 times. Wait, that's interesting actually. An S rank costs 2. Increases rank to A. Refill all AP. But sets self-health to 1. That's interesting as well. But for solo, it kind of sucks. That would be insane in group play. Deal high single target light damage, 5 hits, damage increased by speed difference with its current target. No, but that would be amazing because then I can play like I could play her with Ajid, right? Like imagine that plus Ajid. He just wins the game. But I play solo because I like playing solo. A lot of his kit is based off of group play though. Right. Let's continue. We have to do a tutorial basically, figure him out. What am I supposed to do next?
Mon ami. Oh, you've put on a lot of weight.
I could say the same for you, you giant marshmallow. Bet you lost your stones again.
You know me. But now you're here. We can go find them.
I'll be
Yeah,
fat.
buddy.
That's okay.
We'll find them. Tell me, did you tell them about... you know what?
Oh, maman's the word. I promised.
Great. I'm counting on you.
Always, mon ami.
You want to spend some time with Eskia? Sure.
Verso, mon ami.
Esquier, mon ami. I feel like I haven't seen you in years.
I like this guy, man. He's likable, unlike Gustav.
3 years.
Good change.
67 days. And roughly 10 hours.
10 hours and 7 minutes.
Oh, you've been counting too.
Roughly. Did Francois finally move out and get his own cave?
Francois would miss me too much. He hates napping alone.
If you're here, then isn't he napping alone?
Oh, he must miss me so much right now. Poor Franfran.
Or Franfran.
I'm sure he'll survive.
Yes, yes, yes.
So how did these expeditioners convince you to leave your cave?
They're all so nice. Well, the super nice one died, but the others are cool too. You can make some friends too. It's been a long time since you made new human friends.
You know what I think about friendships with expeditioners.
Losing a rock is better than never having
Wisdom.
a rock. Ask
Wisdom.
me how I know.
Debatable.
I hope we won't lose them, like the others.
So, you lost your stones again. How did you lose them this time?
Yeah, I lost them on our trip back from the Chestrel
Eskia's
River
rock. He
right
rocks.
after you left.
Oh, don't worry. I hope you get them back.
You are the best. I missed going on adventures with you.
Me too.
Eskia and Verso rekindle the flame of their friendship. Okay. Relationship level. Okay, nice, nice.
To adventure.
There it is.
Mon ami.
I could say the same for you.
Yeah.
Mam-
Great.
Always.
Alright, same conversation. What else do we have to say? Understandable. Listen, Chad, before I even learn how to play him, it's happening. I've already committed, baby. It's over, chat. I have committed. Verso all in. I don't care. I don't care. This guy's cool. I like him. It is what it is. All in Verso, baby. No going back. Haha. That's what I like to say.
Expedition Zero left 67 years ago, which would make you
old.
About 100. Yeah.
Tell me about the fracture.
I'm not gonna get much sleep tonight, am I?
You know, that's like a double unto Dure. I'm not gonna get much sleep tonight. Neither is she. She agrees. All right, bro. I'm gonna say something. my boy Gustav, he literally died like 5 minutes ago, and she's already cool. She's cool with it. She likes this guy better. Look at her. No grieving, no nothing, chat. Gustav's gone. She's already into my boy here.
Oh my
Look at
god,
that.
bro.
Expedition Zero.
About 100.
Tell me about the fracture.
No sorrow.
Provides
Easy
essence when collecting high quality plants.
All right. It's fine.
I mean, fine, why not?
Yep, Gustav's gone, brother. The disrespect.
Okay, so more collection for...
Can we upgrade
Ooh,
the
those
accuracy?
earrings are actually very nice. I like those.
All right.
Then...
All right, real quick, Verso for... We have a lot. We have 20 points we can put in on him. So what do we want to put? Healing parry is pretty damn good. Oh, look, wait. Confidant costs 20.
We'll figure out how to...
Wait, what?
Oh my god, I unlocked the tides.
So
Oh my
bad.
god. I unlocked the...
Costs 20. I could just equip it, but then I
I'm
lose.
totally not
I
ruling
just
out for
equip
an
it
outfit
instead of
right now. Totally.
I think Confidant's amazing, by the way. I think it's actually insane, except for boss fights.
The... Okay,
you
the
know what?
stars are
We're kind of rich, we can
different.
afford
I
it.
guess
20
there's
of
different
these.
collection, basically.
All right.
Let's see.
What are my objectives?
Let me
Go
go.
through the Forgotten Battlefield. All right. Pick accuracy
There's
again.
still some... What is this? Where will the bubbles go? And
Next morning.
unresolved mystery. Let's go here. Okay.
I had 76 attributes. Oh, really? All right, I'll fix it. She's the only one mourning Gustav. Well, I guess because she's his sister. Makes sense. Okay. Psychopatate outfit? Yes, sir. Boost agility for stat. Yeah, I'll boost all of his stats in a sec. She looks dumb in the emotional scenes. No, she's like a sad clown, bro. It's a very known trope.
Peak cinema.
Peak cinema. Now we just need a cool outfit
Really
for my
sorry
boy
I didn't arrive
for
sooner.
Verso. Yo, weren't there merchants who sell stuff that we couldn't buy because we didn't have Verso yet? Like previously? Or am I wrong?
He was your brother.
Something like that.
What do you mean something like that? Huh?
Losing family is difficult.
Giovanni Giorgio. Italiano brain rotto.
You want to offer your condolences. You want to say something comforting.
I love that Italian
I don't need it.
is getting represented now.
I've had enough.
No, I only came here just to get fucked in the ass hard. What the fuck?
So many families now.
Okay, I need to go from here to there.
Can you please go?
Alright. Let's go. I feel like Gustav's gonna come
Italiano.
back though, chat. I feel like, but maybe not. Maybe he doesn't.
I hate when they do that. Like, killing characters is supposed to be emotional. It's supposed to, like, help you grieve. And when they come back after a death, it's just... I don't know. It leaves... It's like one of the cheesiest storytelling narratives. Because it's like... What's a good way of me making something really, really emotional? Oh, he dies. Okay, what's a good way of, like... No, but I don't want to deal with the plot repercussions of a character's death.
Love to see it. Alright, I'm gonna go to the bathroom.
Because
Be
now
right
I have
back.
less dynamics in my story.
1 second.
Lee's back again, you know, like... Come on, bro, like, you have to... You could write better than that, like, what the fuck? I don't know, man. I feel like there's just no weight to anything if you do it that way. You know. Where is it? Am I going in the right direction? Oh, okay. I'm at the wrong elevation. No, that's the lobby stuff. No, I'm happy. I'm happy. I'm good. I'm nice. I don't even fucking know what I'm saying. Oh my god, that looks so cool. Oh shit. Holy fuck, what's going on?
Alright, we're back. We're back, chat. Sec. If you didn't realize, I know he has very similar skills. I'm aware of that. Whew. Alright. Let's dive back in. Also, I don't know if Loud Alley is still here. Thank you so much for the 20 bucks for the donut, for the super chat. That's really kind of you. Thank you very much again. I don't know, confused. So where are we now? We are on this continent. Okay, we can swim now, by the way. And because we can swim, I think we want to go down there first.
Head for the monolith, through the quarry to the north.
Screw that. I want to go south. You're cycling at the gym? Got it. Well, thank you. Thank you very much.
Let us get wet.
Oh boy. Alright. This guy's gonna sell me something. Just wait for a chat.
Speed.
He's gonna give me a... These are expensive. Haircut for CL? It's kind of hot though. Like that. Wait, no, not you. But it doesn't fit with the outfit, dude. Okay, I gotta go with this. I shouldn't have bought it. It was a mistake. I shouldn't have bought it. Woo! Boys, he can swim. Holy! But what are those? Wait. I don't know if I can fight those guys, can I? Yeah, I probably don't want to go there yet. Surely I won't die here. Wait. Ah! I forgot my attribute points, chat. I almost threw. I almost threw, chat. Alright. Look at his passives and stuff. I need to properly deck him out. I also gotta see his weapons. So inventory weapons for him. What do we have? 50% increased base attack damage. Increased damage on rank D. No damage increases on other ranks. On rank D, recover 20% health with base attacks. I mean, it's a cool base attack build. I could definitely see myself playing that. Not even joking. I think that's spicy, but that's level 20 as well. What do we have here? Don't lose rank when taking damage from powerless enemies. When taking damage from powerless enemies. I don't know what the hell are powerless. +1 perfection on hitting powerless enemy. Apply powerless on counterattack. Okay. Interesting. The debuff, got it. Start battle on rank B, but 50% health. Recover 50% health on base attack. Apply powerful on rank B. Interesting. This is definitely not it, because I have permanent powerful. When hit, lose 1 perfection instead of
I did not know that working with people is so fucking hard. I'll be honest. Like, I think this guy's just misunderstanding how to work in teams, bro. Like, genuinely. Like, I don't understand this. Jesus Christ. I understand it's very stressful having a master's degree, like, but you don't need to, like, put it all on me. Like, what the fuck have I done, bro? Like, I want to be done with this task as much as you want to be done with this tasks. Like, what? Like, Oh. Like, just asking to explain the plots, like explain what they do. Like, that's the only thing I was just asking about. Mm. Like, like, what is he? I'm not. understand there's this big ass frustration. Like, I've been there. Like, I've been there when I was like so fucking pissed and so fucking frustrated, but like, you don't need to. Just send a message, bro. also to plot visually the data. Not line plot. What is it called? Like, man, I just had about this.
Okay, but what if we have more? Okay, but it will be calculated here.
You asked for feedback. I am not saying what's right or not. You asked for feedback. I gave you feedback. Like, Jesus Christ. Shit. Oh my god, bro. Oh no, bro, like, this shit is crazy, man, like, what are you all about? Direkt, bro. Is it because of the K nearest? Is his whole schmaz that I don't use? I don't think I want to work with people anymore. I understand why people don't want to work in groups anymore, I'm not gonna lie. Jesus Christ. Like, what am I listening to? Yeah, I took 5 neighbors. Canon-modellen min bruker 5 neighbors istedenfor hele datasettet. Like, like,
by using Seaborn per plot. You just need wait a little bit and it will be calculated. And that's it for this demo. Making it hard
Bro, I'm like, oof. I think I'm good with this game. Holy shit, this thing is like frying my CPU, bro. Oh, I'm gonna take a break.